So the recording has started. Today we are at day 5. Okay. So guys, how many of you had a chance to go through the homework? I know the homework that I sent was pretty late. I sent it on a Thursday. I could have sent it earlier in the week, but Thursday I was on leave. I took leave from office on Thursday. So that was the only day I got time to prepare some homework for you guys. Okay. So I prepared it in a hurry. Otherwise, there was no plan of sending a homework to you during that week. From next week, I plan to send some homework, but until last week, there was no plan. But anyways, did you get a chance to look through the questions? But if you had gone through my videos and all the materials that I have sent so far, and if you understood everything, the homework will not take you more than 5 hours, is what I believe. Okay. So guys, did you look through the homework? So how was it? Difficult, easy? Did you complete it, Bharat? Okay, so Bharat has completed the homework. That is great. Okay, so some of the questions are tricky there. So a few questions I intentionally made them tricky. Yeah, great. So, but guys, you will be able to do. Maybe some of the questions will require loops, if loops, while loops, and some of the questions will require nested loops. Okay, but they are easy. They're not difficult. Okay, so try it yourself, and you guys can discuss within yourself. So Bharat has almost completed. So if you guys need any help, you can always ask Bharat. Okay. And maybe I can also discuss. But I will want you guys to do it yourself instead of me telling you because the questions are easy. Okay. Okay. And any doubts so far, guys? Any doubts do you have in whatever we have covered? So are the videos helping you? Are you watching the recordings? And are the videos clear, easy to understand, or are there any disturbances in the video? Okay, no disturbance. So good, good. Bharat, the questions were pretty straightforward, so I don't think you will need to verify. Okay, so for example, the training data set that I sent you, okay, so there if you want to verify the answers, you can just do the same operation on the Excel also. So the Excel which I have sent you, try to do the same operations on Excel, and if your Python code's answer is matching with the Excel's answer, that means you are correct. So you can self verify basically. Okay, and the other questions where I have asked you about to create to identify prime numbers and all those things, you can verify directly from the answer. You don't need any help there. Okay, so try to do that, otherwise I'll be helping you if you're stuck in some of the questions. Okay. Okay, so let's start with, so we'll do a quick revision of all the things that has been covered so far. Okay, so maybe 10 minutes I'll spend in revision, and then we will move ahead with today's topic. Okay, so what did we do so far? So let's first discuss the Python portion, then we will move to the stats portion that we have discussed. Okay, first let us discuss all the Python portions that we have discussed, starting from the data types. Just a quick revision. Okay, so we saw what are lists, right? So what are lists? Collection of elements, collection of items, right? Collection of items, and they can hold multiple data types, right? They can have a string, they can have an integer, and other data types also. We define them by using square brackets. Okay, next what did we see? We saw tuples. Okay, so what are tuples? They are defined by first bracket, and they also can have multiple data types. They can have multiple data types. What is one key differentiator of tuples? They are immutable. Okay, what does that mean? That means once defined, their values cannot be changed. Their values cannot be changed. Okay, lists are mutable. Lists are mutable, you can change their values. Okay, tuples are immutable. and otherwise they are pretty much the same. Lists and tuples, they are pretty much the same. They both can hold multiple data types. The syntax is different. You define a list using square brackets, a tuple using first bracket. Okay, but the elements in the tuple are immutable. Okay, next what did we see? We saw dictionaries, right? So dictionaries, they are defined using curly braces. You have a key value pair. Okay, key value pair separated by a colon and then by a comma. So this is key 1 value 1, this is key 2 value 2, and so on. Okay, now the keys in a dictionary are immutable. Okay, so you cannot change the keys in a dictionary. Okay, so that means your keys in a dictionary cannot be lists, they cannot be another dictionary, and so on. Okay, it has to be one particular item, not a collection of items. Okay, so that is about dictionary, and dictionaries are unordered. Unordered key value pairs. What does this mean? Unordered? Unordered means you cannot access them by index. You cannot access them by their index. So the concept of index does not apply to dictionaries. Okay, that is what is meant by unordered dictionary. Next, what did we see? We saw sets, right? We saw what are sets. They are also defined using curly braces. They are unique items. They can also have multiple data types. They can have also string, and they can have integers. They are always unique. Okay, and they are also unordered. That means you cannot access a set by its index. Okay, this I am not very sure, but I think it is. Maybe someone, I think I have mentioned this in the files that I shared. I think I have mentioned this, but I'm not very sure of it right now. I think they are unordered. Sets are also unordered. You cannot access individual elements in a set by their index, so the index thing will not work on sets as well. Okay, what else did we see, guys? Tuples, dictionaries, sets, series. Yeah, we saw series. So what are series? Yeah, series, arrays. So series are also just like lists, but they will have a label also along with it. Okay, pretty simple. They'll have a label plus the data. Okay, and they are very similar to a list. They can also have multiple data types. Okay, next we saw arrays. Arrays were coming from the NumPy library. Okay, from the NP library. Arrays will have one data type only. So this is a big difference in arrays. Okay, between array and lists. Arrays can have only one data type. Okay, and the other thing to note with arrays is, if x is an array and if you do x into 2, what will happen? It will multiply each element by 2. Okay, this is what happens if x is an array. But if x is a list, if x is a list and if you multiply it by 2, what will happen? It will repeat the entire list twice. So if it was 1 2 3, it will become 1 2 3 and 1 2 3 again. Okay, it will repeat the entire list 2 times. Okay, so this particular thing that we see here is known as broadcasting. So arrays, we can broadcast a array. That's what it is called. I'm not sure why they call it broadcasting, but arrays, we can broadcast a array, but we cannot broadcast a list. Okay, or you can say, in other words, in simple words, you can say we can we can do any operation on individual elements of an array, but not for a list. We cannot do like directly. Obviously we can use comprehension and we can multiply these by 2, but if you have to do it directly, arrays support direct element operations, but lists do not support. Okay, okay guys, do you agree with whatever I'm talking? Okay, next what did we see? Comprehension. Okay, So comprehension, again, they are defined using square brackets. What we do, we first do what we want to do, and then we write for I in a list, let's say, if this is a list. So for example, if you have to multiply everything by 2, we write I into 2 for I in X, where X is a list. Okay. So just another form to avoid the loop. Instead of a loop, we are writing a comprehension here. We will see why they are very helpful later. I'll give you some assignments where you can do things easily using comprehension, and even in the examples that are present in the files which I have sent, you can see the usage of comprehension. Okay. Then we finally move to data frames, right? The most important data type, which is the data frame. So what are data frames? Data frames are nothing but collection of series, collection of different series. So each column in a data frame is a series. Each column is a series. This is series 1, this is series 2, series 3. Or you can also say they are arrays, because each column will have one data type only, right? So they are, you can also call arrays, but officially they are collection of series. Okay. So this is what we saw in a data frame. Then we saw a few other concepts where we want to access individual columns. Yes, Karthik, I know that. That is why in the homework assignment I gave you the hint. In the homework assignment I gave you the hint, right? How do you read a data frame? So I know that. So we will cover that today. Okay. Okay. So next we will see, we saw what is slicing and dicing of array. Okay. Slicing and dicing is a complex word for subsetting a array or filtering a array. Okay. How do you subset array, or how do we filter array? Yeah, the input function also. Yeah, so Vinod, I cannot cover everything in the class. So there are thousands of functions. Okay, I cannot cover all the functions. So some of the functions I intentionally give you as a homework so that you explore it on your own, because I am not able to cover it in the class. Okay, so that was an intentional question which I gave, where you had to ask the input from the user. Okay, so that's why I wrote you are free to Google. So you can always Google for answers. Okay. So next we saw was slicing and dicing. So we saw how do we access individual columns in array. We just write data frame and we write the name of the columns, right? This is what we do. If we have to access multiple columns, we pass all the columns as a list inside. So let's say this is column 1 and this is column 2. So both these columns we will be able to access. Okay. So this is for columns. Next we saw the LOC function. What does the LOC function do? If we have to access rows by its name or columns by its name, we use the LOC function. So how does it work? So data frame dot LOC, you can write which row you want to access. Okay, if the row has a name. So what was the syntax, guys? Can you tell me what was the syntax? How will we write? Let's say we have the data frame which is this. Okay, and we have some values here. Let's say 1 0 2 5 9 8. Okay, so how do we write? Okay, in LOC do we write like that? Column name access is equal to 1. So let's say I want to access these two, 2 and 5. So how will I write using LOC? This is the row names. Okay, X, Y, and Z. So how will I write? What will I write for this? To access 2 and 5? Yes, guys, tell me. Y and B. Aurangzeb, not B, because I want both, right? So I'll just, so I can write only Y here and instead if I want A and B, it's up to me basically. Okay, so I cannot write 0 here, okay, because this LOC function will only take labels, it will not take the index. So I'll have to write A and B as a list. Okay, so this is how it will work. And the same function, now the same, if I have to access using the indexes, then I will use the ILOC. So I will write data frame dot ILOC. Now I cannot use the label because I have used ILOC. So I'll have to use the index of it. So what is the index of the second row? It is 1. So first row, which columns do I want? I want the 0th column and I want the first column. So I will write 0, 1. Okay. Here, no, columns is not required. You can directly write A and B. Columns is equal to is not required. Okay, Ashwin. So these two will work. Both will give me the same output 2 and 5. This using the labels, row label, column label. This using the indexes. Okay. So this is about slicing and dicing. You can also slice based on some condition. So let's say I want to select all values which are greater than, let's say, 5. Then how will I write? In a column C, I will write data frame, then data frame, then whichever column is greater than 5. Then I will get only those rows for which column C has a value greater than 5. Okay, this is how you will filter based on a condition. Similarly, you can have multiple conditions followed by and or. You can have multiple conditions like this. So data frame, you will have condition 1 here, condition 2, condition 3 and so on. Okay, each condition will take the form like this. Data frame and the column and whatever condition you have. Okay, so this will be like one condition. It has to be in this syntax. Okay guys, so this is about slicing and dicing a data frame. Okay, anything else did we see in, we saw some functions, the sum function, the maximum function and all, right? But that is pretty simple, so I don't think we have to revise that as well. Okay, anything else did we cover in a data frame apart from all this? No, I think this is what we covered, right? So we are good. Okay, so now let us move to the, yeah, the loops. I think it's pretty simple, so I don't think I'll have to review the loops, right? There's nothing new there. It's the same C++ syntax that we have been following so far, right? Yeah, same, similar. Okay, so let us do a quick, uh, let me, okay, let me continue then. So yeah, so let's cover the drop function. So let's say what if you want to drop a, if you want to drop a particular column, you will just write data frame dot drop, and in a bracket you will write all the columns that you want to drop, right? All the columns that you want to drop, let's say column 1, column 2 and so on, and you will give access is equal to 1. Okay, access is equal to 1 is to drop columns, access is equal to 0 is for the rows. Okay, and if you want to overwrite, you will write in place is equal to true, otherwise you will not write this. If you don't want to overwrite, don't write this. Okay, so we saw drop. Okay, what else guys? We saw how do we merge multiple data frames together, right? Using the concat function. Concat function from the pandas package. So pd.concat, we write as a list, we write all the data frames that we want to concat. Data frame 1, data frame 2 and so on. Okay, and we write access is equal to 1 or 0. So if you are doing a, if we are concatenating this way, this plus this is a column concatenation, we will write access is equal to 1. But if we are concatenating it in this way, this plus this, we write access is equal to 0. So this is R bind, this is C bind for people who know R. Okay, this is how concat function works. What else did we see? We saw the merge function also, right? I think did we see the merge function? Pd.merge, did we see that? Okay, so we'll see that today, so don't worry about it. We will see that today. What else did we see guys, before going to the loops? In changing data frame, how, what else did we see? Okay, I think this is all. Okay, now let us come to the loops quickly. So what did we see? We saw the if condition, right? We saw if and elif, right? So if condition 1, you give the quotation, and you remember the indentations. Indentations are very important in Python. Okay, you give some indentation here, so whatever comes after indentation is inside the if condition. Okay, so if this condition is true, all statements with one indentation here will be executed. Okay, if you give your condition 2, so this is condition 2, this is condition 1, again you give a indentation, so whatever is after this indentation will be executed if condition C2 is true. Okay, and at last you will give your else condition. If none of the conditions are true, this is what will happen, whatever comes here will be executed. Okay, so this is your if loop. Next we saw for loop. Okay, for loop is very simple. You just write for, and with an indentation you write all your else statements to be executed. Okay, so for example, if you have to, for loop, what it does, it goes through each element in the, whatever you write here. If it is a list, each element in the list one at a time. Okay, first element, then second element, third element, and so on it will go. Okay, so you can write for I in any x, where x can be an array or x can be a list. Usually it is a list. Okay, that means it will go through each element of the list one at a time, and then you can take that element and do whatever operation you want to do. So for example, if you want to find if it is an odd number, take each element one at a time and then divide it by 2. If the answer is, if the remainder, if there is a remainder, that means it is an odd number. If there is no remainder, that means it is an even number. Okay, and so on. So this is the syntax of for loop. Then we saw what is a while loop. So while loop, what was the syntax? So while, you give some condition here and followed by indentation, you write all your statements. Okay, so this is also similar. So you give some condition here. So let's say while I is greater than 5. Okay, so these statements will be run until your I value is less than 5, less than or equal to 5. So always remember, in a while loop, you should have a increment operator of y. Something should be there which changes the value of y. If the value of y does not change, and if this condition is always satisfied, it will become an infinite loop. So you'll have to make sure that this condition gets like not satisfied at some point in time, otherwise it will become an infinite loop. Okay, so that is a while loop. Then we also saw break and continue. Okay, so break, what it does, so let's say you have inside the while loop, let's say inside while loop, if we are inside while loop, you have a break statement somewhere here. Okay, so whenever you reach this place, break, what it does, it will come out directly. Okay, not, let me not explain it here, let me explain it separately. Okay, so let's say break and continue. Let me give you a small example. Let's say if I is greater than equal to 5. Okay, you print I. Okay, and I write another if I is equal to 4, break. Okay, and then I write print I again. Okay, and then this is it. So this is the condition. Okay, now let's say my initial value of I is, let's say, 2. Okay, my initial value of I is 2, and somewhere here I write I is equal to I plus 1. So what will happen now, my I will be 2 at the beginning, then this can, okay, no, not 2, let me make it less than equal to 5. Okay, let me make it less than equal to 5, and let me make it 4. Yeah, now it is okay. Now initially your I is 2. So this condition is satisfied. I is less than equal to 5. So your 2 will be printed. So this print I 2 got printed. Now it will check I is equal to 2. So this condition is not true. It will not go inside this. It will come here again because this is part of this loop, right? It will not go inside this, but here it will come. Okay. So print I, it will again print 2. Then I will become 3. Okay. I will become 3 now. Now I have given a if condition here. I think I should give a while condition, because if it is if, it will not go back again to run. So it should be a while condition. Okay. Let me give a while condition here. So now it will print 2 2 this way, then it will go back. Now once it goes back, now the value of I is 3. Okay. So 3 is less than 5, yes. So it will print 3. It will not go inside this again. It will print 3 again. Okay. And then 3 will become 4. 4 is less than equal to 5, yes. So it will print 4. Then what will happen? If I is equal to 4, break. So break means it will totally come out. It will come out here. It will not go back to while loop. So that's all. The process will end here. This is the output you will get. Okay. Done. Now how will things change if we have continue in place of break? Now let's say I don't have the break here. I have continue here. Okay. Now let's see how the output works. Okay. Now I starts from 2. I is less than equal to 5. 2 will get printed. 2. Then again 2 will get printed. Then 2 will become 3. It will go again 3. 3 will get printed. Now the value of I is 4 here. Okay. So print I 4. 4 will get printed. Now it will go inside, and this condition is true now. So it will continue. Continue means it will not run whatever is below it. So this iteration will not happen. It will straight away go to the next iteration. So it will become 5. It is equal to 5. Okay, actually this print should have been here. Okay, so basically the point I am trying to make is, with continue what happens? It goes to the next iteration. Next iteration, okay. With break what happens? Comes out of the loop. Totally, entirely it will come out of the loop. With continue it will just go to the next iteration. Okay, it will not run whatever is below that continue. With break it will come out of the entire loop. Okay, with continue it will go to the next iteration. That's it. Okay, got that, guys? Okay, don't worry, just do an example on this. I think the file that I have shared has an example. Just do that example, you'll understand. And I don't think this will be used, so don't worry about it a lot. I have never used this ever, but it might be asked in interviews. That is why I tease this. Okay, now what else? Anything else did we cover apart from the statistical part? Sorry guys, I had muted myself. I don't know why. Okay, so descriptive statistics. So descriptive statistics is when we basically describe a population with a few parameters. Okay, so the parameters are mean, for example, mean. Okay, median, then mode, standard deviation, quantiles. Okay, so quantiles means 25th percentile, 75th percentile, 50th percentile is already here. So using these, okay, so using these parameters, if you describe a population, this is nothing but descriptive statistics. Okay. Okay, so standard deviation, very important. The definition of it was root mean square of deviations from average, right? This was the English definition. The mathematical definition was start from the opposite, average, so take the average, deviation from the points, so xi minus average, this will give me the deviation. Root mean square, so square it, take the mean divided by n, then take the square root. This is your I goes from 1 to n. This is the formula for standard deviation. Okay, very important concept. We will see why standard deviation is so important. Today we will jump into the normal distribution and we will see. So this is what we saw, and you can find all of these parameters in Python using the describe function. Remember the describe function? You just write data frame dot describe. Okay, it gives you all these values. It doesn't give you the mode, but all the remaining values it will give you. Okay, next we saw what is a histogram. So what is a histogram? See, histogram is always for one variable, and that should be a continuous variables, right? So guys, everybody knows what is a continuous variable now, right? I don't have to go into that revision again. That was covered in the first week. Okay. Okay, so a histogram is histogram is a plot for a continuous variable, one variable only. It cannot be drawn for two variables at a time. Okay, so one variable, it looks something like this. Okay, what do you have on the x-axis? Yes, guys, tell me. What do you have on the x-axis? CV. What is CV? Okay, the variable. Yeah. So whichever variable. Yeah, the continuous variable. Okay. Yeah. Sorry, I have never called them CV. Okay. So this is the variable, and here what do we have on the y-axis? The frequency. Okay, it can be the frequency or it can be the probability. Okay, it can be the probability also. Frequency when it is a count, probability when it is count divided by total number. Okay, it can be PDF also, probability distribution function. So it will look something like this. Okay, this is a normal histogram. What does it tell you? Let's say the value of the variable here is 10. Let's say we plotted age and this is 10, and the height of this is, let's say, 15. Okay, the value is 15 on the y-axis. So what does this mean? This means that there are 15 people or 15 records in your data for whom the age is 10. This is what it represents. Okay, similarly, if this is, let's say, 30 and this value is, let's say, 20, that means there are 20 records in your data for whom the age is 30, and so on. Okay, if we get this as a probability, let's say we have 100 people. Okay, we have 100 people, and then this probability will be 0.2. Okay, then this will be 0.2 because 20 divided by 100, so it will be 0.2 if it is a probability distribution function. So this is histogram. How do we draw histogram in Python? Yes, guys, tell me, which function do you use to draw histogram? Hist function. And from which package does it come? It comes from the library matplotlib, right? Matplotlib dot pyplot. You import this as plt, right? And then you use plt dot hist. Okay, and then you pass data frame and whichever column you want to plot. If it is age. Okay, this will give you the histogram, and then you can write the labels plt.x labels. You can write within quotes whatever you want. Plt.y label, similarly plt.title. Okay, this will give you the title of the entire histogram here. Okay. If you have to use Seaborn to draw histogram, you can also use Seaborn to draw histogram. There it is known as a dist plot, a distribution plot. Okay, just a different name but the same plot. So you use a oops, you use a dist plot if you are using the Seaborn package. Okay, so there the syntax is SNS. So import Seaborn as SNS, SNS dot dist plot. This is what you write, and you give the same data frame, the variable you give. This will draw the same histogram plot. Okay, you also have the option of changing the bins. You can change the bins to any number you want. If you want more detail, you increase the number of bins. Okay, if you want a finer histogram. Okay guys, everything making sense whatever I'm talking? Okay, great. Next, what did we see? We saw what is a box plot. Okay, box plot, very important. Why is it used? It is used to detect outliers. Okay, okay, outliers in data. So it typically looks like this: box plot or box and whisker plot. Okay, you might have a few points outside these will be the outliers. So you will have here, you will have the median, okay, or the 50th percentile. This is your Q3, this is your Q1, right? Q3 is 75th percentile, this is your 25th percentile. Okay, then this distance is known as IQR, interquartile range. And how much is this distance? This is Q3 plus 1.5 times IQR. Okay, this distance from here. So this entire distance, if you have to measure, let's say this is the axis, then this particular distance is 1. Q3 plus 1.5 times IQR. Similarly, this distance is from here to here is Q1 minus 1.5 times IQR. Okay, this is the distance. So we say outliers are all those points for whom the value is less than Q1 minus 1.5 times IQR and greater than Q1 plus 1.5 times IQR. They are all outliers. Okay. How do you draw box plot in Python? Again, if you are using matplotlib, okay, yeah, sorry, this is Q3. So plt dot box plot, and you give the same value, data frame and the column name. Okay, if you are using Seaborn, you write SNS dot, what do you give for Seaborn? Again, it is box plot, right? I think it is box plot, yes. So for Seaborn also it is box plot, you give the same input. Okay, so pretty simple. We saw many other plots also in when we were doing Seaborn package, but even I don't remember the commands for all of them. But just if you guys remember, you might have read it recently. I did not read it after taking your class. Okay, so I think a few of them where we saw. So what were those? We saw what is pair plot, right? Yeah, we saw joint plot also. Okay, what was pair plot? Pair plot, I think it was the one which gave a scatter plot as well as a histogram, right? Remember we got two histograms, one for the x value, one for the y value, right? That was the pair plot, right? That was the pair plot. Okay, and what was the joint plot? Can somebody tell me what was the joint plot then? If this was the pair plot, what was the joint plot? I think joint plot we had the option of giving a hue, correct? We had the option of giving a hue, so we could color the plot based on different categorical variables, right? Right guys, am I right? Okay, so hue was for pair plot, so I confused the two. Okay, so hue was for pair plot and joint plot was this, I think. Yeah, I think even I was skeptical of this. So this will be your joint plot and this is your pair plot. Okay, Okay. So I think the plots is okay if you forget, but have the codes handy so that whenever you need them, you can draw plots. So when we will doing the when we do the case studies, we'll be using a lot of all of this. So that will give you a good practice. Okay, so this was all that we covered so far. And I don't think I'll have to go back and tell you what is a continuous variable, what is a categorical variable. Inside categorical variables, what are nominal, what are ordinal, or what are continuous, what are discrete. I think you all remember that, right? That was covered in the first week. Okay, guys. So this was the entire course so far. Okay. So let me just save this file and then we will start with today's session. So today is day 5. Yeah, I was in a hurry to quickly cover everything because I have to move ahead also, right? We are going very slow actually. Okay. So if I was taking the same course for the institute, I would have reached maybe logistic regression by now. But that's okay. So I intend to go slow with this batch. I want you guys to really understand the things. That is why I'm going slow. Okay, so let me open up a new sheet now. Okay, so let's start now. Just a minute, okay? So what do you want me to start with? Should I start with Python? I have some statistics to be covered today and some amount of coding also. What do you want me to start first? Should I start with the coding first or should the statistics start first? Okay, coding. Okay, so let me open up the sheet then. Wow, man, you guys are all coding geeks. I also started with a batch for R today. So that was for Emarticus. That is in R. The fees for that batch is 55,000. But that has R and Python both, not just R. Okay, let me go to just a minute. Okay, 1 minute. Get the file. Karthik, nice one. I had one. Yeah, this is it. Okay, so this is the file. Let's start. Have I started the recordings? Okay, yeah. Thank God I have started. Okay. So again, guys, some of the things written in this file, I'll be sending this file today. So some of the things in this file will not be required for you. Okay. So just because I wanted this document to be an exhaustive document so that you don't have to go to any place else to read Python, I have included the things. Okay. But some of the things are totally irrelevant, so I will just skip them. And even if you want, you can skip them basically. That is not required. Okay. So these simple things for printing, how do we print, and these lambda expressions, they are not very important from a data science perspective. They are important for Python developers, but in data science we very rarely we use these functions. Okay, so we can skip them. So I will straight away come to things which are important, which is the data frame part. Okay, so this one. So now we will be dealing with missing values. So a lot of times when we start with a project, when we start with an actual industrial project, so we will not have data always given to us in a very nice way. For example, the previous data that we worked on, remember the tips data set where a few customers had paid tips and all, we were studying that data set. So you will not always have data set, or you will rarely have a data set in that way. Okay, in a cleaned way. Usually the data set will be very dirty. It will have a lot of missing values, outliers, and it will also have multiple data sets you will get. So multiple tables or multiple CSV files you will get. You'll have to merge them together and then come up with a final data set where you can work on or where you can apply your machine learning. Okay. So missing values is one of that pain which we have to. Yeah, example of dirty data set you will see, Karthik. So next week's homework you will see a lot of. I'll send you some homework where you will have a dirty data. You'll have some outliers. You will have some missing values. And again, the quality of the data depends on the industry you are working it. Okay, so if you are in banking industry, the data sets in banking industry are usually pretty clean. Okay, because banks they have invested long ago into their infrastructure to store the data and all, so they have pretty clean data. But if you are working in, let's say, marketing, then your data will be very dirty. Okay, so it depends on which domain you are working in. So according to that domain you might have the quality of the data might vary based on the domain you are working. Usually marketing is very has a lot of dirty data. Okay, but banking and all, they will have proper data sets. I'll try to give some the homeworks that I give you on those will have some dirty data, not a lot, but it will have some missing values, some outliers which you might want to change. Okay, so let's see how do we identify missing values in our data. Okay, first. Okay, so to identify missing values in data, the function that is used is called is null. Okay, is null is a function which is used to find missing values. Okay, so missing values are represented as nan in Python. Okay, in R it is na, in Python it is nan. Okay, so always remember, wherever you see an nan, it's a missing value. That means, and missing value is different from a space. Okay, the moment you give space, it is a string. It is a string with a space. Okay, but nan is, that means that value is totally blank. It is not even a space. Okay, I hope you know that. So how will you find whether a data frame is whether a, let's say, a row has a missing value? Okay, so let's say if I ask you, how will you find if a row has the value 5? This is easy, right? You will just write a condition data frame data frame, then the column name is double equal to 5, right? This is what you will do if you have to filter out all the rows which has a value 5 for column C. You will do this. Okay, but the same will not work if it is a missing value. You cannot write something like this: data frame column is equal to NaN. This will not work. Okay, this is wrong. This is totally wrong. Okay, this is wrong. Why it will not work is because nan is something undefined. Okay, you cannot use equal to equate with a nan. Okay, it is undefined. So one nan is not equal to another nan. This is also wrong. Okay, one nan is not equal to another nan because it is undefined. You don't know what it is. Even this, you don't know what it is. So how can they two be equal? They cannot be equal because both are unknowns. Okay, so it's like infinity is not equal to infinity. Okay, because this is also very big. This is also very big. Is nan equivalent to null? Yes, you can say it is equivalent to null. So in case of Python, null, we define null as nan basically, not junk value barrel. So let's say I'm a bank. Okay, I'm a bank and you have come to me to apply to basically ask for a loan. Okay, now I gave you a form to fill. I've given you a form to fill where you have to fill all your details, and some of the columns are mandatory, some are optional. Okay, you can fill some columns, for example your name, your age, your income. All these things are mandatory, but some of the sections are optional. So for example, anything, let's say how many kids you have and so many details, so those are optional. So what will you do if it is optional? If you are in a hurry, you will skip those options, right? That is what we usually do when you apply for a internet or when you apply for a sim card. What do we usually do? We just fill the options which are mandatory and rest we skip. So all those skipped portion, if the bank is digitalizing its data, all those skipped portion will become null values. Null values is nothing but nan values basically. All the options that you skipped will become a null. Okay, yes, it is. And nan is not a number, but in Python it is read as, see, it is read as, even a null is read as not a number because you don't know what it is, right? So they treat it as not a number. Okay, so that is how it is. Okay, and you have a function in NumPy library to define a nan. You can write it as np.nan. Okay, you can define a variable x is equal to np.nan. Okay, that means this is a null value. You cannot directly write nan, you can write np.nan. So it is a function. That way you can define a variable with np.nan. Okay, okay, now let us come to the codes. So what are we doing in the codes? We are first defining a data frame which has some nan values. Oops, yeah, so first I import the libraries. I have imported numpy, I import pandas. Okay, now I have defined a data frame. I'm using a dictionary to define a data frame. So how have I defined? The key is a and the value is a list. You see, the value is a list 1, 2, and the third value is nan. np.nan I have written. Okay, that means it's a nan. Similarly, I have defined the second key is b and the value is 5, nan, and nan. The third key is c and the value is 1, 2, and 3. Okay, now when I print the data frame, it looks like this. Yeah, so the values of the dictionary, the keys of the dictionary become column names and the values become the values in the column. Okay, so this is how it looks. So one I have here, then I have 2, and then I have nan here. Okay, similarly I have 5 nan and nan here, and third is nothing but 1, 2, 3. Okay, and notice wherever you have nan, it is taking the other as a integer, as a floating number, not an integer. Okay, this is an integer, but this has become a floating number. Okay, because there is a nan present there. Okay, so now let us see how can we do operations on this data frame where we have some missing values, some nan values. Okay, now let's say the first thing that we want to do, we want to delete all the nan values. Okay, we want to delete the nan values. So I will just write, so let's say I want to, oops, I want to delete the nans. I don't want any missing values to be present in my data. Let's say I have this data 1 2 3 4 5 nan and nan 3 2. Okay, this is the data frame I have. This is A B C. Okay, this is index 0, index 1, index 2. Okay, I want to delete all the nans in my data. Okay, so if I want to delete all my nans in my data, how should I delete it? I cannot have a data frame which is like this 4 5 and 3 and 2. I cannot have something like this. I cannot just delete this, or I cannot just delete this. I will either have to delete this entire row, or I'll have to delete this entire column. Similarly, I will either have to delete this entire row, or I'll have to delete this entire column if I have to delete this nan. Okay, that is how it works. Getting, guys? Are you getting? Guys, please respond. Guys, can someone respond? Okay. Yeah. Yeah. For example, if you are reading data from a CSV file and the value there is blank, so it will automatically become a nan. Okay, Karthik? Let's say you are reading, because in data science we usually read it from some source, right? You read it from a SQL table or you read it from a CSV file. So if in the CSV file it is blank, it becomes a nan. But since here we are creating our data frame on our own, we are explicitly writing nan. Okay. Yes, Prajwal, we will see that now. Okay. So now if we want to delete the nans, we either have to delete the entire row or we either have to delete the entire column. Okay. Otherwise, how will it, we cannot have something as we discussed, right? We cannot have a data frame with just these values and no value here. Again, it will become nan only, right? Because if it is nothing, it is a nan. Okay, so you either delete this entire row or you delete the entire column. Okay, so you have to decide basically what do you want to delete. Do you want to delete the entire row which has nan, or do you want to delete the entire column which has nan? You have to decide. You cannot have, basically you will have to delete this entire row or this entire column, or you can replace this nan with some value. Okay, but if you are deleting the nan, you will have to delete the row or the column associated with that nan. Okay, so you make a choice and then you use the drop function. We use the drop function for that. The syntax is like this. So we write data frame dot drop. Okay, and then we write axis is equal to 1 or 0 depending on what do you want to delete. Okay, if you want to delete the row which has nan, you write axis is 0. If you want to delete the column which has nan, you write axis is equal to 1. And again, if you want to overwrite, you use true or false with in place. If you want to overwrite or not, depending on that. Okay, clear, guys? Yes, you can replace nan with anything, Bharat. You are free to do that. If your business suggests that you do that, you can do that. We will see that as well. Okay, and that is the best approach actually. We should not delete nans. We should replace them with a more appropriate value. But since we were discussing the coding part of it, let's say you have 10,000 data. Okay, you have 10,000 details of customers. You have details of 10,000 customers. Out of them, some, let's say 2 or 3 customers have not filled some information, so you can delete them. Why will you take the headache to fill details for just 2 or 3 customers out of 10,000? because your model will do good on 9998 also. Those two data points will not make a difference to your model. So if it is very small, you can delete it. Okay. Usually if your missing values are less than 1 or 2%, you can easily delete them. Don't take the headache of filling because filling these missing values requires a lot of thinking. We will see that filling missing values or filling the outliers requires a lot of logical thinking. You have to think from a business perspective how you should fill the values. So if only 1 or 2% is missing, you can directly delete them. Why will you take that headache? Okay. Yes. No, if it is less than 1 or 2%, you can directly delete them. You can directly delete them. But if it is more than 1 or 2%, then you replace them. Okay. Something has to be done. Either delete or replace. Something has to be done. Okay. You cannot leave them as it is. Okay. Let's see the function. So see here, this is the data frame I have. Now I'm just using data frame dot drop na. I did not write axis is equal to 0 or axis is equal to 1. So what is it by default? By default, is the axis 0 or is it 1? So correct. By default, the axis is 0. Okay, that means rows. So by default, the rows will be deleted which has nan. Okay, that means this row will be deleted because it has an nan, and this row will be deleted because this has a nan. So this is what is happening. Only the first row remains because it does not have a nan. Okay. Now you can decide, even if you write axis is equal to 0, the same thing will happen. You can write axis is equal to 1. Then what will happen? This column will get deleted and this column will get deleted. Only column C will remain if we write axis is equal to 1. And this is what is happening. Okay, pretty simple. Now you can also give a condition like this. So for example, delete all rows with less than or more than 2 nans. 2 or with more than 2 or equal to 2 nans. Okay, so this is one row which has 2 nans, right? So only that row will get deleted because I have given a threshold of 2. So you can write it like this: thresh is equal to 2. That means an axis is equal to 0 means it will delete rows. That means it will only delete those rows which has 2 or more than 2 nans. Otherwise it will not delete. Do you understand, guys? It will only delete those rows which has 2 or more nans. Okay. Okay, so now we have seen how do we delete missing values. So delete missing values is done. Oops, why did I start in the middle? Okay, now let us see to the other part. So deleting we have seen already. So this portion is done. Let us see this now. How do we replace? Okay, so for that we can call it filling missing values. Filling the nans. How do we fill the missing values? Let us see that now. Okay, it is pretty simple, very simple. Just like deleting, you use something called fill na. This is the function that you use to fill missing values. Okay, so how is the syntax? Let's say fill na, and you write value is equal to with whatever value you want to fill. So somebody said, can we fill them with 0? You fill them with 0 here. So give 0, it will fill all the missing values with 0. Okay, this is what it is used. Okay, this syntax. Let us see it in Python. So see the same data frame which we have here, this data frame. I am filling all the nans with some value. So we have 3 nans, right? I am filling it with this value. The value is itself fill nan. Okay. So see how it looks like. After filling nan, it looks like this. Instead of nan, I have fill value, fill value, fill value. See this? I have filled all the missing values with fill value. Or if you want, you can fill it with 2 also. See here, I have filled it with 2. So instead of nan, you have 2. This 2, this 2, and this 2. This 2 was already present. So these 3 2's came here instead of nan. So very simple. Just write data frame dot fill na. Okay, and then write value is equal to whatever value you want to fill. Okay, clear guys? How do we fill nan? Okay, great. Okay, let's say you have a column called age missing. Then if you want to fill that age with the median of age or the mean of age, the average of age, you can fill it in this way. So see, I'm filling column number A. So df and A, because I want to fill only this column. I don't want to fill all the values. I want to fill only this value which is present in column A with the mean of the column. So what I have done, df, I have selected the column, then dot fill na, and in value I have written df A dot mean. Okay, so that means it will fill with the mean, and in place is equal to true. So I'm overwriting it. So what happens? What is the mean of 1 and 2? It is 1.5. So I have 1.5 here. Okay, this is also pretty simple, right? The syntax is also similar. Earlier we were filling for the entire data frame, so we wrote entire data frame here, but now we are filling just for one column at a time. Okay, so I wrote only that column, not the entire data frame. Okay, and value is equal to, I just wrote the mean here. Okay, this is how you calculate the mean, right? Data frame, select the column for which you want the mean, and then dot mean. Okay, this is another way to delete all the rows. Same, this means axis is equal to 0. So both these are same. Okay, now if you want to create a new column which has all nans, you can create like this. So data frame, you write the name of the new column and just write is equal to nan. So it will create a new column which has only nans. Okay, I don't know why is this required. You will never want to do this, right? But just out of curiosity, if you want, you can do that as well. Okay, now let's say you have a data frame. Okay, and you have some missing values in the data frame. Okay, you have a data frame. Now we will see finding the count of nan in each column. Okay, how will we find how many nans are there in each column? So if you remember, if you write data frame dot info, remember we saw this command in the previous class. This will give you how many missing values you have. Okay, this command gives you how many missing values are there. But additionally, if you want, but this gives you a lot of other information also. This will give you for all the columns. Let's say you don't want for all the columns. This will also give you the data type and other details. Okay, let's say you don't want all that information. You just want how many columns are, how many values are missing in each column. So what you can do, if you write data frame dot is null. Okay, if you write this, this is like a condition on the data frame, on each column of the data frame. So let's say if we have data frame 2 3 1, you have a nan here, 0 2 0 nan, and again nan. Okay, and let's say this is your column number A, column number B, column number C. Okay, now if you run, and this is your data frame df. Now if you run this command, what you will get, you will get, so for 2 it will check is it null, no, so you will get false. For nan it will check, so you will get true. For 0 it will be false, it is not nan, right? For each column in the same way, A B C. 3 it will be false. Okay, I'm writing only F. This is also false, this is true. Similarly here it is false, for 2 it is false, nan it is true. So you understand what it will do? It will check for each element in the data frame, and it will check whether this condition is true or not. Okay, okay guys, you understand this? Data frame dot is null, it will check for each column, for each element in all the columns, whether it is null or not. Okay, now using this you can basically know, because we know that false is nothing but 0 and true is nothing but 1. This is the value, okay, for each true and false. So if you add all of these values, you can get the count of missing values and non-missing values, right? If you add the entire column. Okay. So what you can do, the same code, you can transform it a little. You can write data frame dot is null dot sum. If you write this, what will happen? It will add the columns, and what you will get for A, this is 0, this is 1, this is 0, so you will get 1. For B, you will get false is 0, 0, 1, so you will get 1. For C, you will get 0, 0, 1, so you will get this. Okay, so that means column wise you are getting how many values are missing. So for A, 1 is missing, which is true. For B also 1 is missing, C also 1 is missing. So you can use this function to find how many missing values are there in each column. Okay, this function is very helpful. Okay, because first we have to find how many values are missing, only then we can fill the missing values, right? So this is how you find which column has missing values. Very important function. Okay, just let's see it once. So I have, okay, so for example, this is what I was trying to say. See, np.nan is double equal to np.nan is false. Okay, yeah, this function I was telling, right? So see, if this is your data frame, this is how is null dot sum will give you. Okay, it will give you a1, b2, c0. So c, there is nothing missing, so it is 0. B, there are 2 missing, so 2. 1, only one value is missing, so 1. Okay, so Barail has a question: how to fill first nan with one value and another nan with other value in the same row or column. So Barail, we usually fill the missing values row wise, okay, column wise. Okay, we never fill the missing values in a row wise fashion. Okay, why? Because this is as per the business understanding. See, I'll tell you, makes a lot of sense also. I will just tell you. So let's see, for example, you have a bank data. Okay, so I'm a bank, people come to me and apply for a loan. Okay, and let's say these are the details I have collected from the customers, from the potential customers basically. Okay, this is their name, their age, their gender, their income, and so on. Okay, this is what I have. Let's say they have some names, some values are given. A few people have not given their age. Okay, this is blank, and a few have not given their income. Okay, so this is how it looks like. So this is person number 1, person number 2, person number 3, person number 4, and so on. Imagine there are thousands of rows like this. Imagine there are 10,000 rows like this. Now for age, I have a few missing values. Okay, now you will not fill them in a row wise fashion, right? Because you never know what is the age of this person. You don't know. But you can fill it in a column wise fashion because you can aggregate it. So this entire column you will pick out the entire age column, and obviously the people applying for a loan will fall in some range, right? You will not have a child applying for a age, so maybe people applying for a loan fall in this category, maybe 28 to 38. Okay, usually that you will get from the data itself, you don't have to do anything. And let's say what you will do, you will find the average age, the average age of all customers that have applied for a loan, and that average value you will fill here. That is what is usually done. So that average you will fill here and here. Okay, so you can do the same function that we saw. You can use data frame, then the column age. Okay, dot fill na. You can write value is equal to x. X is nothing but x is your data frame, then age dot mean. This is your age value. Okay, this is your x. So this x you are filling it here. So that means this value will get filled by the age, this value will also get filled by the age. So age column will not have any missing values now. Okay, we are done with age column. Clear, Berail? Did you understand? We will never fill it with respect to columns. With respect to rows, we always fill with respect to columns. Okay, with rows we never do that. But if you want, you can always access this, right? Let's say you want to fill this, then you can find the index of this row. So you can write data frame dot iloc, and then you can write whatever. Let's say this is row number 2, so you can write row number 1 is equal to, and you can give the column name here, and you can write, let's say this is equal to 22. Let's say this is a friend of yours, you know that he is 22 years old, you can write it like this also. But this is usually not done. We fill it based on columns only. Similarly for income also you will do. You will find the average of all income, and then you will fill the income value. You will not fill all the NA values together, because the average age is not the same as the average income, right? It is different. So you will fill them independently. Okay, one column at a time. This is how we fill the missing values, one column at a time. Yes, exactly, Bharat. We fill one column at a time because we know that the column has the same variable. So even if one value is missing, we can easily find it. Or if we replace the missing with a mean, even if it is wrong, it will not be very wrong. Okay. You cannot fill all the values with the same variable. So let's say average age is, let's say, around 29. You cannot fill the income with 29. What if the income is in lakhs and everybody has, let's say, 5 lakhs, 6 lakhs? Then it will be huge, right? Or let's say gender is missing and 90% of your applicants are, let's say, female. So you will try to fill the missing values with female. You cannot fill female for age. That will be totally wrong, right? So one column at a time you will fill. This is how the missing values are filled in data. Okay. Okay, cool. Now let's see what we have ahead. Okay, now very important. We have group by. But let me take group by after doing the merge function. Let me first take the merge function. Concat function I had covered already, right guys? pd.concat. Yes, Prajwal. We fill it for columns that way only. And you will never be filling with respect to rows, because the data that you get, you will not have a friend in your data, right? For which you will know some value. The example which I gave, that let's say the second guy is your friend and you know his age. That will never happen, right? So we always fill it with columns. Okay. Okay. So concat function had we seen before, guys? Concatenating two data frames. How do we concat them? I think we had seen them before. Okay. Okay. Aurangzeb says no. Okay, no problem. I will just cover them quickly. So two functions, merging and concatenating, very important. Okay. Joining is not important. Merging and concat is very important and very simple. Merging is same as SQL merging. Okay. For people who know SQL, it is same as how do you merge two data frames. Okay. So let us see that. So first let us see concatenating. Concat two data frames. Okay. Two or more data frames. Okay. Let's say we have a data frame df1. Okay. You have a, b. You have 1, 3, 9, 11. You have another data frame df2 that also has the same columns. Let's say 3, 9, 11, 12. Now let's say we want to merge these two data frames. Okay. We want to merge these two data frames because they have the same information. So imagine this is age and this is some number. Okay. Any number, some xyz. Okay. This is also age and this is that same number. So we have two data frames which has the same information. So we did not have two data frames, right? We can have one data frame for that. So for that, what we will do, we will merge them together. So how will we merge them? Should we merge them in this way or should we merge them in this way? We already saw this, right? We merge them. Should we merge them in this way or in this way? Which one is correct? One or two? What do you think? How should we merge these two data frames? Two, right? One doesn't make sense because they are the same variable. you'll have the same column twice otherwise. Okay, so we will merge them in this way. So if you have to merge data frames this way, we use functions called, even for both we use the same function, pd.concat we use. Okay, then we write the data frames that we have to merge, data frame 1, data frame 2, and then we write axis is equal to 1 or 0 depending on what kind of merging do you want. Okay, if you want this, the axis is, what is the axis for this? If you have to merge it like this, tell me guys, what do you think? If I have to merge like this, what should I write for axis, 1 or 0? 1 or 0? No, actually it is 0, because we are merging on rows, right? We are merging the rows together, right? So it has to be 0. Okay, because rows is 0 in Python. This is, we are merging columns. So this will be axis is equal to 1. Don't worry, you will immediately come to know. Even if you make a mistake, you can always see this. So let's say you are putting it in df. You can always see what is df, and if it doesn't make sense, you can always go and change it. So it's okay if you make a mistake also in these things, because you know that the answer is either of the two. So if this is wrong, obviously the other is correct. So no issues in that. Okay. So this is how you merge two data frames directly. Okay. So this is the concat function, or this is known as concatenating two data frames. So based on axis. So for people who know R, this is R bind and C bind. Okay. This is your R bind, this is your C bind, this is your R bind. Okay. Same function. Now let's come to merging. This is very important. Okay. How do we merge data frames together? Okay. So let's see. So let's say you have a data frame 1. Let's say it looks age. Let's say this is employee ID. We have employee data sets. Employee ID, age, and let's say his designation. Okay. Let's say employee ID 1, 2, 3, age is let's say 54, pretty senior employee, designation is let's say CEO. He is let's say 52, he is CFO. And let's say this guy is 31 and he is project manager. Okay. This is one data set, and let's say you have another data set, data frame 2, where also you have employee ID and you have let's say his salary. So this data frame is accessible only to the finance guys, only to the finance department of the company, not to everybody. This is let's say Outlook data. This is Microsoft Outlook data. Everybody, okay, age is not present in Microsoft Outlook data, I know, but let's just assume for the time being that age is also present. Okay. Then you have employee ID and you have his salary. This obviously no one can see. So you have the same 1, 2, 3, and let me add some more. Okay, let me add some 5 here, which is 25, and let's say this is software system engineer. Okay, 25 years old. And here we have 1, 2, and 5. Okay, we don't have anything else. This is the only data that we have, and salary we have here. Employee ID, let's say salary is 50 lakhs, or let's say 500 lakhs. Okay, 5 crores. For 2 it is, let's say, how much do you want to give him? Okay, let's give him 1 crore. I'm not giving him from my pocket, right? So let's give him 1 crore. And let's say 5, senior system engineer guy. So I don't know, it will be 0.001 or 0.01. Let's take it is this. Okay. Now there are many ways we can merge these two. Now let's say you want one single data frame. You want all of this data to be in one single data frame, right? This is a typical merge operation even in SQL. So how many of you know SQL? It will be very simple for you. You already know this basically, because the syntax is same as SQL. Okay. So how do we do that now? We use the merge function, merge, okay, from the pandas package. So pd.merge. Okay. So what is the syntax? So before we go into the syntax, let us first understand what are the different kinds of mergings that we can do. Okay, left join, right join, left merge, right merge, inner merge, and outer merge. Okay. So let's see what is left join first. Okay. Then we will see what is right join. So left join is when, let's say you have this table on your left, right? So left join is when this table will become your base. This table will be your base, and whatever details is in this table will start adding to that base. Okay. So first I will write this base. So the base is nothing but 1, 2, 3, 5, 54, 52, 31, 25. Then I have CEO, I have CFO, I have PM, I have system engineer. Okay. Now I will go to the other data and start looking at the salary column. Okay. So the salary employee ID is already present here, so that will not come. The salary thing will start coming from there based on this column. Okay. Based on the employee ID column, not this. So one employee number one is present there. What is the salary? 500. So 500 will come and add here. Okay. Employee number two is present here. So 100. So 100 will come and add here. Employee number three is not present there. So what will happen? It will be a missing value. Okay. This will be a nan because it is not present there. Okay. And this is my base. So it has to be there. Employee number 5.01, it is also there, so it will also come and add here. So you will have this as your missing value if you do a left join. Okay. Now clear guys, left join, is it clear? Very simple. The left table will become your base and additional details will start filling from the other table. Okay. Now let's see what is right join. Right join is very similar, opposite to this. Now your outer table will, the right side table will become your base. So let me write all details from the right side table first. 1, 2, 5. I will have 500, 100 and 0.01. Now it will start filling details from the other table. Okay. So employee number one is present here. So age will start filling in 54 and designation is CEO. This will start filling in. Similarly, employee number two, I will have 52 and CFO. Employee number 5 is present here, so it will come 25 and system engineer. Okay. Imagine I had another column here 6 and let's say it was 10. Okay. Then 6 in the right side I will have this also, but here it is not present, so it will become nan and it will become nan here. This will remain unchanged even after adding this 6 here, but this is how it will be. Now these two will become nan because it is not present in this table, and I'm doing a right join here. Okay guys, clear? Left join, right join, left merge, right merge, let's call them merge. Okay, in some languages we call them join. Okay, similarly you can say there is a concept of inner join also. Okay, there is a concept of inner merge. Inner merge is nothing but only values which are present in both will come. So in inner join no NAs will appear. Okay, no NAs will appear. So that means only only those values which are present in both tables will appear. Okay. So for example here you will have this because it appears in both, this because it appears in both. That's it. You will have only two rows because it appears in both. You will have this in inner join. In outer join what will happen? All will appear. So you will have 1, 2, 3, 4. This is already present, it will come. This is, so everything will come basically. So 1, 2, 3, 5 and 6. So you will have 4. Total 5 rows you will have in outer join. Okay. So in outer join all values will be present. All values is taken. Okay. With nans. So you'll have a lot of nans in outer join. Okay guys, is it clear? This is not commonly used. This is used in some cases, but the most common is left join. This is very popularly used. Okay. So is merging clear to you guys? How do we merge two data frames based on one single column? Okay, based on one particular column. So we are not concatenating them. Okay, this is not concatenation. Concatenation and merging, there is a difference. In concatenation you just bring two things together. Okay, here we are combining them based on one column, which is employee ID here. Okay, so you need to have one common column between the two data frames. So here we have employee ID. Without employee ID we cannot do a merge. Okay, so let us quickly see this in Python now. So that's what I have done. First I'm creating some random data frames. So see, I've created some data frames here. It looks like this. Okay, this is my data frame 1, this is my data frame 2. Okay, so this key is common in both of them. So I'm doing a left join. So let me write the syntax here itself. So this is how the syntax looks like. Okay, so we write pd dot merge. Okay, then we write the data frames that we have to merge. Data frame 1, let's say data frame 2. Okay, then we write how is equal to and on is equal to. Okay, now what is this? On is whichever column you want to merge on. Okay, and the column should have the same name in both data frames. Okay, so example here it was employee id, right? So I'll write employee id. It should have the same name in both columns. If it doesn't have, you change the name and make them same. Okay, only then it will be able to merge. Here you will write left, or if you want to do right, right, or if you want to do inner, inner, if you want to do outer, outer. Okay, inside this quotation you will write. Okay, this is how the syntax looks like, and you can put it in some data frame after merging. Okay, so this is how it will look like. See, that's what I'm doing here. I'm doing a inner join here. So I did a inner join. How is equal to inner, and on which I'm merging on key. Okay, so I have merged on key. Similarly, I can do, I can merge on multiple keys also. See, here I have two keys common, key 1 and key 2. So I can merge on multiple keys also. So I will have to pass both keys as a list if I'm merging on multiple keys. Okay, and again you will have this left and right is nothing but your uh, data frame names. Okay, and if you don't give how is equal to something, by default it will do a inner join. Okay, if you don't write how is equal to something, this is optional. By default it will do inner join. Okay, if you want to do something else, you can write it basically. So this is how you do inner join in Python. Okay guys, clear? Merging operations, how do you merge data frames together? Okay, great, this is very important. Okay, so if you are having a coding interview, so usually people, usually you won't have a coding interview if you are applying for a data science position, but in some companies they have a coding round also. And if you have a coding round, this will be one of your questions for sure. How do you merge two data frames? Okay, I'm damn sure you will always have the merging part there if you are having a coding round. So be clear, you know what is this, and it might be on multiple columns, not just one column. Okay, so for example, this example that I gave, merging on two columns. Okay, this is pretty simple. How do you find unique values in a column? So just write the column name and then unique. This will give you all the unique values. So see A0, A1, A2, A3. And if you want to find how many unique values are present, just write n unique. Okay, number of unique. It will give you 4. Okay. Have we seen this already? Value underscore counts. I think we have seen this, right, guys? Okay, we have seen this already. Counter, have we seen the counter also? Yes, I think we have seen the counter also. That is why I gave these questions in the homework. Okay. Okay, now here are a few examples of reading different files in Python. How do we read different files? So somebody asked me, right, that reading a CSV file was not covered, so it is present here. See, so if you have to read a CSV, this is how you read a CSV file. Okay, just pd.read underscore CSV. You write the name of the CSV file. Okay, it has to be with the extension. Okay, just write the name of the file with extension. It will read the file. Now if you have to write a data frame as a CSV file, you have a data frame, let's say df, and you have to write a CSV file, you write data frame dot to CSV, to underscore CSV, then you write the name of the CSV file again with extension. Okay, so if you have to write this data frame file as a CSV, you write data frame dot to underscore CSV. If you have to read a CSV, it is read underscore CSV. So very similar to what is done in R also. So for Yashwant and Prajwal. Okay. Similarly, if you have to read Excel, it is read underscore Excel. Okay, then you write the name of the Excel. And Excel can have multiple sheets. If you remember, by default it will have 3 sheets, right? So you just write the name of the sheet. If you have to read a particular sheet, you write the name of the sheet. So I have written sheet 1. Similarly, if you have to write into Excel, you will have to write the sheet name also. Okay, so pretty simple. There's nothing to understand here, just syntax. So don't worry, we will be using this a lot, so you will remember it. And then there are some codes here to read HTML files. How do you read HTML file in R, or how do you read PDF files? These are some codes which are used. For that, you'll have to install some libraries. Okay, so for example, you use Beautiful Soup library to read files directly from a website and so on. Okay, this is the function for HTML. So read underscore HTML, and you give the website. Okay, but that website should be in a readable format. Okay, if there are images on the website, it will not read the images, of course. But if it is a text, let's say Wikipedia pages, it will be able to read. But if it is a image or something, it will not be able to read. Okay, don't worry, we won't use this a lot. We mostly deal with this portion, reading a CSV or reading a Excel file. Okay, even if your data is stored in a database, you can always extract data from a SQL database or Oracle database as a CSV file, and then you can read the CSV file, or you can directly connect to a database also using Python. Okay, that is also possible. But since we do not have a database here, we will just uh, do with a CSV file only, but it is very easy. Okay guys, so this was the Python portion which I wanted to cover today. Okay, there is one thing remaining which is also very important, which I basically postponed for the end, because that is the group by function. This is very important. Okay, group by. So let's do one thing. Let's take a quick break. I need a break because I have been talking for a long time. So let's take a break and let us start in 10 minutes. Is that okay, guys? Or you want a longer break? Okay, 15 minutes. Okay, so it's 3:55. Let's resume at 4:10. Okay, let's resume at 4:10. Okay, so 4:10 we will start. We will see group by, and then we will jump to the statistics part. Okay, guys, see you at 4:10. Bye. Okay, so let us discuss the group by function now. Okay, again, this is used a lot in the industry, so let's discuss that. Again, group by is also very similar to the group by which is used in SQL. It is the same, in fact. So for people who know SQL, they will already understand what is group by. Okay, so let's see group by. So let's say I have a data. Let's say again the employee ID data. Employee ID. Let's say I have the department, and let's say his designation, and let's say his salary. This is the data set I have. Employee ID 1, 2, 5, 11, 12, 15, and so on. Okay, department is, let's say he is into the finance department, he is into the marketing department, he is into the HR department, again finance, again marketing. Okay, so these are the departments. Let's say he is the project manager, he is the sales manager, he is the HR. Okay, okay, HR department, I don't know, he is the HR, of course. And this guy is, let's say, senior HR. Finance guy, again, he is, let's say, senior project manager. And in the marketing we have the sales representative or something, whatever. This is the designation. Okay, and let's say their salary is, let's say, 10, senior manager, so this will be maybe 12, HR is, let's say, 8, senior HR is, let's say, 11, Senior project manager is 15. Sales representative is, let's say, 6. Okay, so this is the details we have. Now if somebody asks you the question, okay, let's say there is a new guy, he basically wants to join this company, and he has, imagine he has the option to decide which department does he wants to join. Okay, or let's say you are an analytics guy. So all these departments, they need analytics people, right? Even the finance department also needs analytics. So does marketing and HR also. So in all these departments, we do analytics. So let's say you are an analytics consultant now, and you have the freedom to decide which unit you want to join. Okay, and you want to know that which unit should I join. So your salary will depend on that basically. So you will join that particular unit which has the best salary, right? That is what you will do. You will basically try to join that particular department which has the best salary. So now there are multiple employees from the same department, so you will look at the average salary of each department, right? This is what you will do. And whichever department has the highest average salary, you probably might join that department. Again, I'm not considering the designation here. If you ignore the designation for the time being, then you will join that department which has the best average salary. So that means, what do you have to do? You have to compute the average of salary with respect to each department. Okay, this is the typical case of group by function. These are the places where you use group by functions. Okay, so your final answer will look like your finance department, what is the average salary. Okay, you will get some number here. Similarly, for marketing, you will get some number here. Then for HR, you will get some number here. So this is what we want to find basically using the group by function. Okay, so let's see how we do that. So group by function, we always do a group by function where we have to aggregate, when we have to aggregate based on a column. Okay, and after aggregating, we try to find some value. Okay, so for example, here we want to aggregate based on the department column, and then we want to find the average of some other column, which is salary. Okay, this is where group by functions is used. So I have some examples here also, but let me take this example later. So let us first discuss the other example that we are discussing. Okay, so this one only. So let's say this is data frame. This is the data frame df. Okay, so now what will I write? The syntax will look something like this. Okay, so it will look data frame dot group by. Okay, data frame dot group by, you will start a bracket. Okay, and in this bracket you will write which column do you want to group by on. Okay, so you want to group by on this column, right? You want to group by on department column, so you will write department here. Okay, so you will write, again you can group by based on multiple columns also, but here we are grouping by based on one column which is department, so I write department here. Okay, and then what do I want to do after grouping by? I want to basically find the mean of the salary column. So I will write the column salary here, SALARY, and then I will write dot mean. Done. This is what I will do. Okay, if I do this, I will get the output as, so for finance, what is the average salary? So two guys in finance, 10 and 15. So average salary will be 12.5. So I will get 12.5 as the answer here. Okay, similarly for marketing, what is the average salary? So 12 and 6, 8, so 8 lakhs. No, it's 9. It's 9. Okay, and for HR it is 11 and 8. 8, 9, 10. So 9.5. This is the salary for HR, right? These are the average salaries. Okay, so this is what you will get when you run this function. Okay, so this is the function of group by. So similarly you can find, so I have computed the mean here. You can find any other variable also if you wanted to find the maximum. So how much is the maximum a person earns in each of these departments, you could have used the max function also. Okay, or how much minimum does a person earn, you could have used the min function also. Okay, and you can write multiple columns, you can group by based on multiple columns also, that is also possible. Okay, okay guys, did you understand what is group by? Is it clear? Okay, let us see one more example on this, which is this. Okay, so this is the data that I have, and this is how the data frame looks like. Okay, so you see I have company, person, and I have sales. Okay, so Google, the person name is Sam and sales is 200. Again Google Charlie, sales is 120, and so on for Microsoft and Facebook. Okay, these are the sales. Now what I want to find, I want to find each company's mean sales. Each company's mean sales. Okay, so that means I have to group by based on company now, because I have to find each company. I have nothing to do with person. Okay, so I will group by company, and then I will find the mean of sales. So this is what I do, and this is the output I get. See, Facebook to 96.5, Google this much, Microsoft this much. Okay. Instead of writing sales dot mean, I could have written dot mean also. Just dot mean. Then what it will try to do? It will try to see, this also works, but here it will find mean of all possible columns for each column. Okay, since it cannot find the mean for person, it will find the mean only for sales, because mean for person doesn't make sense. So it will find the mean for each continuous column. Okay guys, so instead of writing sales, I could have omitted this also. If I omit this, what will happen? It will start finding mean of every column. Now mean of person will not make sense, so it will not find the mean of person, but it will find the mean of sales. Now imagine I had some other continuous column here, it will find the mean of that also if I don't write the column explicitly. Okay, but this is the best way, you can write the column name. Okay, similarly again this is the same thing I'm doing, the same things I'm writing again. Okay, so that's what I'm trying to show you. I created a new column. Okay, just a random column I created, and then I'm using sales to find the mean, and without using sales I'm trying to find the mean. So when I use sales, it finds the mean of only sales. Okay, but when I don't give any column, it finds mean of both sales and new column. Okay, that's what I told you, right? If you don't explicitly write a column name, it will find the mean of all possible columns. Okay, okay guys, is group by clear? So it's pretty simple, but very commonly used. Okay, this is very important. So for example, let's say this is data of IPL data. So you have points, you have rank, you have team, and for year. Okay, so you can find various parameters like this. Okay, now let's say if I ask you to find two parameters, let's say in the same data, here if I ask you to find the mean and let's say also the max, I want you to find mean as well as the max, then you'll have to run this function twice to do that. Okay, so there is a shortcut to that. Instead of running the function twice, you can use the aggregate function. Okay, AGG function. That is the aggregate function where you can give what you want. Okay, if you want multiple values, you can write all the multiple values, it will calculate everything. So for example, if I want both min, max and mean, let's say I want all the parameters, I can write something like this. So data frame dot group by, then write the name of the column, which is department. Okay, then you want to find the mean, max, median, and everything of salary. So salary, then I will write AGG. Okay, and then inside this square brackets I will write all the functions. So let's say I want to find mean, So I will write np dot mean. Okay. Then I want to find the minimum also. I will write np dot minimum. Okay. Or if I wanted one more, np dot max, I could have written that also. So three functions simultaneously I am giving. It will calculate me. So it will give me finance, marketing, HR. It will give me the mean, the minimum, the maximum, all the values it will give me in one step. Instead of running this three times, I can use this also. Okay. And we are using this from the NumPy package. Okay. This is coming from the base Python. So np.mean is not required, but this is coming from the NumPy package. So we have to use np.min or whatever. Okay. Okay, guys. I hope this is also clear. Yeah, so this is what is group by. This is what was remaining basically. So this was what I wanted to complete during the week. Just 1 hour of class. That's why I requested that maybe we can have a class one day during the week. Okay, just to expedite the things. But anyways, some of you are busy during the week, so it's okay. Okay, because if we have 1 hour of class during the week, the weekends we can make it 3 hours instead of 4 hours, so that it will become light on you. Because at a stretch, if you take 4 hours of class, you may get tired towards the end of the class. But if you take it in small installments, it becomes easy for you to grasp the things. Okay. Okay, so this is all on data manipulation. Okay, so your Python portion is almost over. So you are done with all the basic data types, the basic cleaning operations that you do in Python. And if you remember all of this, whatever we have covered so far, if you just remember all of this, that is more than enough. Okay, I don't think you will require anything other than whatever we have covered. This is more or less 80% of Python for data science. 80% is covered here. The remaining 20% is again diving deeper into these concepts, creating your own functions and all those. So that is not very popularly used. These are the things which is most commonly used in any industry or in any project of data science. Okay. So based on whatever you have learned, you can do basically everything. If you are given a data, you can merge. If your data is given in multiple pieces, you will be able to merge your data sets. If you want to filter your data based on some conditions, you will be able to filter your data. If you want to identify outliers or identify missing values in your data, you can do that as well. Now you can fill the missing values with a logical value. So all the things you can do. You can draw histograms for your data. You can draw box plots for your data and several other plots which you have seen. So you can do a basic EDA on your data with whatever we have covered so far. So before the modeling step, you can do all the basic EDA. Okay. So EDA is nothing but explanatory data analysis. Okay. This is also very important part of modeling. A lot of insights can be gathered by EDA even before the modeling. Modeling is used for prediction. Okay. Modeling or machine learning is used for prediction. Even before that, we can do a lot of. So this was traditionally known as business intelligence. Okay, the explanatory data analysis, it is still used. Okay, though we have reached the modeling part, but still we do a lot of EDA just to understand our data better. We do this a lot. Okay, so we will do some EDA. So this week's homework that you will get, I will try to send it by Monday or Tuesday. That will be purely on EDA. Okay, even the homework which I sent you already, the last section of the homework where you have to read the data set from the CSV file, that is also some amount of EDA, you can say. Okay, before the modeling stage, whatever you do is your explanatory data analysis. Okay, so let me save this now. Okay, now let us start with the stats portion for today. Okay, so let me just recollect what things we have to cover. So just give me a minute. Okay, so we already covered what is a uniform distribution. Remember guys, what is uniform distribution, right? If I draw a histogram for a uniform distribution, how will it look like? Let's say if age is uniformly distributed, how will it look like? How will the graph look like? Tell me. Yes guys, I'm waiting for an answer. If let's say age is uniformly distributed, yes, exactly, parallel to your x line, a line with slope 0, right? This is how it will look like. Okay, so that means age is uniformly distributed. Okay, this may not be true for age, but for some it might be. Okay, let's say the demand for, let's say, a particular item at a restaurant, it is normally distributed. If I let's say if I draw the demand on a daily basis, the daily demand of, let's say we have a seafood restaurant and the daily demand of, let's say, crab. So let's say on day 1 5 crabs were sold, day 2 also 5 crabs were sold, day 3 also 5, day 4 also 5. On an average 4 or 5 are getting sold every day. So it might vary a little, sometimes 4, sometimes 5, sometimes 6, but overall if you see, it is like a uniform distribution. Okay, so this is how the daily demand for crab at a seafood restaurant is distributed. Okay, now uniform distribution is okay, it is not very difficult. The important part for us is normal distribution. So we are coming back to normal distribution, we will dive deeper now. So first let me hear from you what we have covered so far. So what have we covered so far in normal distribution? Tell me. How does it look like, the histogram for normal distribution? Yep. It looks like a bell curve, right? It looks like this. Okay. This is how a normal distribution looks like. So it looks like a bell curve which is symmetrical basically. Okay. It is symmetrical. Okay. And if I write the equation of the bell curve, let's say if this is y is equal to fx. This is a function of which two parameters? Can you tell me? So this curve is determined using two parameters. What are those two parameters? Yes, the variance or the standard deviation and the mean, right? Remember guys, this is the mean and you have the variance. Variance is nothing but standard deviation whole square. Okay. Sigma is standard deviation, variance is the same parameter. They vary, they basically they measure how widely is the data distributed. That is what they measure. Both variance and standard deviation, they measure your distribution of data. How far is it distributed from your mean? Okay. And a normal distribution will always look like this. It will always look something like this. Okay. It will have a peak at the mean and then slowly gradually it will die away. Okay. Now let us see why is it so important. Okay, we already discussed some examples that a lot of things in nature and a lot of things in businesses, they follow a normal distribution. Okay, but why is it so popular is because of this. Okay, if you know your mean, if you know the mean of your normal distribution, Okay, if this is known to you, and if you know the variance or the sigma, if you know one, you know both, right? If you know the mean and if you know any of these parameters, you basically know everything in your normal distribution. Okay, let's see what I mean by everything. Okay, so let me draw the normal distribution again. Okay, this is your mean. Okay. Now what will be the area under this curve? What is the area under this curve? If let's say this is a histogram of PDF, this is a histogram not of counts but of probability distribution function. This is a PDF basically. Okay, so what will be the area under the curve? What will be the area under this entire curve? 1, right, everybody? This is the total area, right? The total area is nothing but the total probability. The total probability is always 1. Probability can never be greater than 1, right? So this is 1, right? Now here comes the interesting part. In a normal distribution, okay, if you go one standard deviation away from the mean, okay, so let's say this is your standard deviation. Okay, this is your sigma, this is your sigma. So this is your 1 sigma. Okay, they are symmetrical. Okay, my diagram may not be perfect, but they should be symmetrical. So if you go one standard deviation on both sides of the mean, that means on the other side you have mu plus 1 into standard deviation, and on the other side you have mu minus 1 into standard deviation. If you do that, you get 68% of your data. Okay, this is already proved, or we can also prove this. It is very simple. Just find the area under this curve. You get 68% of your data. Okay, you get 68%. Okay, similarly, if you go 2 standard deviation away, let's say 2 standard means you will reach somewhere here. Okay, so if you go 2 standard deviation away from the mean, so this entire red portion, so mean plus minus 2 into sigma. If you go 2 standard deviation away, you get 95.5% of the area. Okay, you get 95.5% of the area if you go 2 standard deviation on both sides. Okay, similarly, if you go which color should I take now? Blue. If you go 3 standard deviations away, okay, that means this entire blue portion. Okay, so that means everything but this blue portion also. If you go 3 standard deviation away, that means mu plus minus 3 into sigma, you get 99.7% of the area. Okay, beyond that you have only 0.03%. Okay, so what does this tell you? This tells you that if you know the standard deviation and if you know the mean of a normally distributed variable, you can basically do any sort of calculations and find out how far is your other data points located. Okay, so let me give you an example just to illustrate this point. So one example would be, let's say, okay, let's say the marks in a test. So the marks of all students in a test is normally distributed. Okay, I'm telling you this. The marks of all students in a test is normally distributed. Okay, the average is, let's say, out of 100. Okay, so this test is on 100. The average is, let's say, 65. Okay, and standard deviation is, let's say, 10. Okay, and standard deviation is 10. Now I ask you, how many students got more than 85? Okay, more than 85 if there are 60 students in the class. Okay, so guys, did you get the question? The question is, the marks secured by all students in a class, the marks secured by 60 students in a class is normally distributed. Okay, and the average marks is 65 and the standard deviation is 10. Okay, now how many students, I'm asking you, the question is, how many students do you think got more than 85 if there were 60 students in the class? This is the question. So can you try once? Guys, try this. Just see the above thing and try to draw this in your rough copy right now and try to find the answer. Okay, try this. It is not very difficult. If I tell you the answer, you will realize it is pretty simple. So try it once, then I will tell you the answer. Okay, so I'll wait for 2 minutes. Okay, I'll have some water and come. You guys try. Okay, so we see quite a variance in your answers also. Some have got 1, some have got 27. Bharat has got 4. So let's see what is the correct answer. Okay. So anybody, others? What about the others? Are you trying? Okay. So before we even jump to the answer, so let's first logically try to see. Okay. So I have said that it is normally distributed with a mean of 65. That means 50% of the students got below 65 and 50% of the students got above 65, right? Everybody agrees with that. So 30 students, since I have 60 students only, 30 students got below 65 and 30 students got above 65. Okay, now my question is above 85, so obviously it will not be somewhere around 27, Aurangzeb. So you understand, Aurangzeb, why your answer is wrong? Because it cannot be 27. Okay, because 30 students have got above 65. So how can 27 get above 85? Very unlikely. Okay, so that means it is a very small number. Okay, now to find that number we will have to dive deeper. Okay, but that intuition you can get just by comparing with that 50%. Okay, so let's try. Don't worry, no problem. It's okay to be wrong. This is a So whatever we are doing in the class is like a laboratory for us. We can do all experiments and fail multiple times here, but we will try to succeed in our interviews and in while we are working. Okay, so let's say this is the mark secured by all students. The average I have given you is 65. Okay, and the standard deviation is 10. So that means the area on the left side of this is, so I have 30 students on this side, I have 30 students on this side. Okay, because the total students is 60. Okay, so 30 on this side, 30 on that side. Now what I am asking you is how many students got above 85. So where will 85 lie? Here. So this is nothing but x and y axis, right? This is your x axis, this is your y axis, this is your marks scored by everybody. Your 85 will lie somewhere here, right? So this is 65, so you will have 85 somewhere here. Okay, okay, so what I am asking you is what is the number of students who got above 85? That means this area I need. Correct? Do you agree, guys? I need this particular area out of this entire thing. Okay, so I have to find this area, and once I have the area, I can multiply that area with the total number of students. I will get the answer. Okay, so let's see how we can find this area. Now I have also given you the standard deviation. Okay, so first you will have to calculate how many standard deviations away are you from the mean. Okay, so this is 65. Now how many times you will have to add standard deviation to 65 so that you come here? How many times will you have to add? 20 times? No, 2 times, right? Because the standard deviation is 10, right? So you will have to add 65 plus sigma and then again plus sigma to get to 85. So 2 times you are adding sigma. Okay, so you can also find this by using this x minus x bar, okay, divided by mean. This is the formula to find how many times you have to add the standard deviation. Okay, okay guys, do you agree? This is nothing but this is called z value. Okay, yeah, okay, Vinod, got it. Yeah, I got your answer. I understood you were trying to say that. Okay, okay, so that 2 that you got, right, that 2 is nothing but it is known as z value. Okay, so what is z value? Z value is nothing but how many standard deviation away is your point away from the mean. Okay, how many standard deviation away from your mean is the actual point into consideration. That is given by the z value. You can calculate this using this formula. You did it without using the formula, but this formula also can be used. Okay, but you can do it without using the formula also, right? Because 65, if you add 2 times the standard deviation, you reach here. If you use this formula, it will be 85 minus 65 divided by 10, which is nothing but 2. Okay, so this is again, this is known as a z value. This is very important. Okay, we will talk about this a lot. This is the z value. So z value is how many standard deviations away from mean is your point of consideration. Okay, so we got that as 2 now. And what do we know? We know that if you go 2 standard deviation away, so if this is 65, we know that if you go 2 standard deviation away on both sides, how much area do you get? You get 95.5%, right? If you go on both sides, okay, 2 sigma on both sides, if you go, you get 95.5% of the area, right? This I have told you already. This is here. Okay, now what I can do, but I don't need only this area. I want this also. I want this plus this, right? I just want everything but this. So if you just take 95.5% of 60 students, it will be wrong, because I want this also. Do you understand, guys? I want from the beginning till this point, not just from here to this point. Okay, I don't want just this. This is wrong. I want from the beginning till here. Okay, so what I will do? So this is 95.5. What does that mean? That means what is the remaining portion? What is the remaining here? The remaining is 4.5 divided by 2. Do you agree? Because the total is 100%. So this is nothing but 2.25, right? This is 2.25. So can I add 2.25 here for this? So from the beginning till here, how much will you have? You will have 2.25 plus 95.50. This is what you will have, all the area till here, till this point. Okay, how much will that be? 75, 97.75. Okay, so everything till here is your 95.75, which means how much is this then? This is nothing but 1 minus 97.75. So if I convert it to decimals, it will be this much. So what will remain? What will you get after this? So you will get 2.25, right? This portion. This is your 2.25. You could have directly got from here. You did not calculate actually. So 2.25% of total students got above 85 marks. Okay. So we can calculate that as a number now. 2.25 into 60. Again, how much will you get? So 5 twos are 10, 2 fives are 10, 2 threes are 6, 5 fours are 20, 5 fives are 25. Okay. Okay, it is 2.25%, right? Oh shit, I made a mistake. Just 1 minute, guys. It is 2.25%. I made it to 25%. Okay. So it will be 225 divided by 100 and into 60. So you might get a decimal number also, because then again I did not frame this question properly. So you might get a decimal number out. Let's do this. So 225 into 60. So how much are we getting? Divided by 4 zeros. 1, 2, 3, 4. So we are getting 1.3. So 1.3 is our answer. If you round it off, it will come to 1. So only one student got above 85. Okay. So I think somebody gave this answer, right? I think a few people gave 1 as the answer. I think it was Karthik. So well done, Karthik. So I hope you calculated the answer in the same way, and you did not just guess it, right? Yeah. Yeah, good. If you did this calculation and if you arrived, it is very good. Okay. So guys, all of you understood, right? How using normal distribution we can answer such questions. Is it clear now? So similarly, so this is more of a academic question, but in the businesses also you can have things like this. So for example, let's say a bank will want to know that, okay, what is the probability? So this is nothing but probability. The bank will want to know, okay, how many of my customers above 60 years old? So above 60 years old means probably the customer is a retired customer. So how many of my retired customers default on their loans? They will be able to make a guess, okay, based on these parameters. Okay, and how will they decide whether the variable follows a normal distribution? Because they will have the entire history of data. So the entire history of data, they will plot a histogram for that, and if the histogram looks like this, they will know that, okay, my data follows a normal distribution. Okay, so this is how this is useful. Okay, normal distribution, very useful. So I have a few other examples also. So if I show you a few other questions on this. So I have a few other questions. I'll give some of them as a homework, and some, let's do at least one now, or at least let me talk about the questions. I'll give them as a homework. Okay, but at least let me talk about the question now. So let's say, for example, this question. Okay. So let's say the GMAT scores are normally distributed. Okay, the GMAT scores are normally distributed with a mean of 580 and a variance of 10,000. So variance is given. That means you can calculate the standard deviation. Okay, if variance is 10,000, the standard deviation is 100. Just square root that and you get the standard deviation. Now, what is the probability that a randomly selected student score is at most 780? So what does this mean? So this is your score of all the students. It follows a normal distribution. The mean is 580 and sigma is 100. Okay. Now what is the probability that a random selected student score is at most 780? So 780 lies somewhere here. And what am I asking? I'm asking at most 780. What does this mean? I want area on this side or that side. Which side? This one? Less than 780 or more than 780? What do I want? At most. Left or right, guys? So when I say what is the probability that a randomly selected student score is at most 780, that means I'm talking about the left side area, right? So you have to find this particular area. Pretty simple, right? You can do that. Okay, very simple, right? You will just find z. What is that value of z? And if that z is 1, you know it is 68 plus 1 minus 68 divided by 2, right? The way we calculated, the same way you can calculate. But first you will have to find z. Z is nothing but how many standard deviation away is this point from the mean. Okay. Now the next question is at least 500. So the next question is, if this is your 580, now 500 is on this side of 580. Okay. So 500 is somewhere here. Now my question is, what is the probability that a student score is at least 500? What does this mean? Left side or right side? Now right side. Yes, correct, Anish. So now it means I want the right side information. So I want this particular area. Okay. I want this particular area. So if you know left, you can always find a right. 1 minus left, if you do, you will get the right side area. Okay. Now what is the probability that the score is between 500 and 600? So now what do I want? I want the score, if this is your 580, I want between 500 and 600. So I want this area to the left as well as to the right. Okay. And similarly, now this question is a little different. This will be your homework. This question is, below what score do 95% of the scores lie? Now I am not asking you the area, but I am asking you that point. Where should that point be? Okay, let's say if this is your uniform distribution, this is your normal distribution, sorry. Now where should that point lie so that below what score do 95% of the scores lie? Okay, so what am I asking? Find that value here. It can be any place. Now I'm asking you that value. Until now I was giving you the value. Now I'm asking you the value, but I'm giving you the probability. So that below that 95% of your area lies. Okay, so 95% of your area lies below that value. What is that value? So that z you will have to find. Okay, and you know z is x minus x bar by sigma. Sigma you already know, x bar you already know, z I have given you, 95% is your z. So you have to find the x. Very simple, right? All other examples I have given you x, I want the z from you. Okay. Here I have given you the z, you have to find the x. Okay. Guys, are you getting this? This is very important. Okay. Or if you want, we can do all these examples right now. Or you want to try them on your own? Yeah, sure. So you guys can try once, otherwise we can take it up in tomorrow's class. Okay, but at least try this one and try this today. Okay, try this before tomorrow's class so that if you are not able to do, at least you will be able to tell me that what problem are you facing. Okay, so that we can discuss about this tomorrow, because this is very important. Yeah, good, Kavya. So let's go back. Now, one, it is not always so simple. Okay, one thing to catch here is, let's again come back. Let's say my mean is, let's say 50, standard deviation is, let's say 5. Okay, so now I know that if I go 50 plus minus 5, that means if I am from 45 till 55, I get 68% of my area. If I am from 40 till 60, I get 95.5%. And if I am from 35 till 65, I get 99.7% of my area. Okay, but what if I am somewhere in the middle? Okay, this is one standard deviation, this is two standard deviation, this is three standard deviation, right? But if somebody asks you, what if I am 2.5 standard deviation? Okay, then how much area do I cover? So this is for one standard deviation, this is for two standard deviation. Okay, what if somebody asks you, I am here, I am 1.5 standard deviation. Now what is my area, what is this area, if somebody asks you? So that also you can calculate, but you cannot remember for all, right? For these three you can remember, you can commit to memory these three numbers, but you cannot remember for any random number, right? It can be any number, 1, 1.2, 1.5. There can be so many other numbers like that, you cannot memorize all. So for that we can take help of software. Even these you can get from software. So we can take help of Python for that. Okay, so what we'll have to write in Python, we will just write, basically we will give the z value. So z is nothing but x minus x bar divided by sigma. Okay, we will give the z value in Python, and Python will automatically tell us. So the z value will be positive if you are greater than mean, and the z value will be negative if you are less than the mean. Okay, if you are on the left side of the mean, your z value is negative. If you are on the right side of the mean, your z value is positive. Okay, you know this equation, right? If you are subtracting from the mean, and if your x is greater than the mean, it will be positive. If your x is less than the mean, it is negative. Hope you are getting everything, guys. Okay, so if you feed the z into one formula which we'll discuss now, it will tell you what is the probability. Basically it will give you the probability if you just feed the z value. Okay, so this whatever we discussed so far is known as z test. Very important in statistics. Okay, this will come back to us when we are discussing machine learning. Okay, so this is all known as, whatever we are discussing is known as z test. Okay, always remember this particular thing is known as z test. Okay, so z test is used for a normal distribution. Okay, it comes from a normal distribution where you try to find the z value. Now what is z value? This is the formula to calculate z value, x minus x bar divided by, okay, this is sigma. Okay, I made a mistake here. This is sigma, not mu. Mu means mu and x bar is the same thing. Okay, this is sigma. You divide it by the standard deviation. Okay, so z value is nothing but how many standard deviations away from the mean is your point of consideration. That is your z value. You must remember this. Okay, don't worry, if you do a few examples, if you practice a little, you will remember. It's not very difficult. Okay, this is your z test, very important in statistics. Okay, now similar to z test, you have something called t test. Okay, very similar. You won't get confused, don't worry. Don't be angry that I am explaining you two difficult concepts on the same day. This is very similar. Okay, so z test is used when your number, the number in your whatever variable you are studying. So for example, in this case it was students, right? It was students. So if your number is a large number, okay, if your number is a large number, we do a z test. Okay, if your number is usually greater than 30, if your number of, for example in this case the number of students, if the number of students is greater than 30, we do a z test. Okay, but if your number, in some cases you will find you are doing for a very small number of people. Okay, if your number is less than 30, if your number is less than 30, then we cannot say that they follow a normal distribution. Okay, if this is your normally distributed variable, we cannot say, because less than 30 is a very small number to find. No, less than 30, not percent, 30, 30 number. So we were talking about students here, right? So we had 60 students, right? So 60 students, that is why we comfortably assume that it is normally distributed. If it is less than 30, we will not be able to make this assumption. Okay, not 30% or 50%. I'm talking about absolute number. Not I'm not talking about probability now, Bharat. I'm talking about the absolute number. Okay, we had some numbers here, right? So that number is 60 here, for example. So if my variable of interest is less than 30, if my variable of interest is less than 30, then I cannot say that my variable follows a normal distribution. Okay, I will not be able to say that. In that case, your variable might follow a t distribution. So t distribution is very similar. If this is your normal distribution, your t distribution will look something like this. So what is the difference between normal and t? This is your t distribution. Okay, what is the difference? The difference is here in this. So it has wider tails. Yeah, you can say more variance, but it has more wider tails. Okay, t distribution has wider tails. So these tails you see, they are higher than normal distribution. Okay, or you can say they have slightly higher variance also, but they have wider tails here. That is the difference between normal distribution and t distribution. So if your number is less than 30, you can safely assume that your variable is that your variable follows a t distribution. Okay, not a normal distribution. In that case, we don't call it a z test. We don't call it a z test, we call it a t test. Just the name is different, the formula is same. Here we find the t value, same formula, x minus x bar divided by sigma, but we don't call it z value, we call it t value, and this is the t test. Okay, very simple. And there is a slight difference. The normal distribution, it has smaller tails. The t distribution, it has longer tails. Okay, that is the only difference between z test and t test. So these two tests are very important. We will see them once we discuss linear regression and logistic regression. Okay, and once we discuss hypothesis testing, which will be tomorrow. Okay, so take a moment and see if you understand everything, and then ask me if you have any doubts. So take a moment. I will allow you to just understand and try to recollect whatever I have told till now about z test and t test, and see if you understand everything. Yes, Bharat, sure. So see, whenever your number of whenever your population or sample size, so this is nothing but a sample, right? Whatever students I told you about, these are all samples from a population. Whenever your sample size is very small, when your sample is very small, if your sample is very small, you will not be in a very good shape to tell that my variable follows a normal distribution. Okay, even if the shape looks like this. Let's say you took sample of a few people, let's say 25 guys. You went around and asked 25 people what is their salary basically. Okay, and let's say the distribution looks something like this. You asked them and the distribution looks something like this, and you asked only 25 guys. Okay, you asked only 25 guys what is their salary, and it looks something like this. So if it looks like this, now you will be happy that okay, it follows a normal distribution. I can find everything. I can find everything basically, who earns how much, what is the probability of somebody earning, and all the things you can find. But this sample size is too small. Okay, it is too small to come to the conclusion that it follows a normal distribution. So in these cases, it is not fair to assume that it follows a normal distribution, but you can assume that it follows a t distribution. So you can assume that it follows a t distribution instead of a normal distribution. That you can safely assume. Okay. So that is the only difference. Otherwise, it is the same. So always remember, whenever your sample size is usually 30, whenever your sample size is less than 30, then we use a t-test, otherwise we use a z-test. That's the only difference. Otherwise they are the same. Yeah, the definition of small sample is if it is less than 30. That's what. If your sample size is less than 30, that means it's a small sample. Okay. So whatever examples I have given, I have already told you that they are normally distributed. That means it is more than 30. So if it is already told to you that they are normally distributed, you don't have to ask any question. Since they are normally distributed has been given in the question, you can safely go with the z-test. But if it is not given, and if you are given the sample size and the sample size is less than 30, that means you will have to decide based on the sample size which test should you go. Should you go to a t-test or should you go to a z-test? Okay. All right. So before this, I think I was discussing, what if somebody asks you, what if I go 1.2 times, or what if I go 1.5 times away from the standard deviation? How much area will I get? So let us see how we calculate that using Python. Okay. Let us see. So just give me a minute. So let me show you with a new Python notebook. So let me open up a new Python notebook. Oops, not a text file. I want to open a Python file, right? New Python. Okay. So for that, we'll have to use a new library. I think it comes pre-installed in Python. So the library name is SkyPy. Okay. So I will write from SkyPy dot stats. Okay. Oops, why is it not writing? From SkyPy dot stats import, from SkyPy dot stats import norm. Norm is for normal distribution. Okay. And I will run this. So this function I will be using. Okay. So how will I write? I will write norm dot ppf. Okay. So this is to get the probability. Okay. Percent probability function. ppf stands for percent point function. Okay. Don't worry about that. Just you'll have to remember this. There is no other way. Okay. So norm, don't worry. You can save this somewhere and you can refer to this. So norm dot ppf. So here what do you write? You give inside this, you give a probability. You give a probability to get z value as output. Okay. To get z value as output. This is what you do in this function. Okay. Now let's say if I write norm dot ppf and if I write this, what will be the answer? Who can tell me? what will be the answer if I run this command? Don't run and just don't run, guys. Just see and tell me. So what I'm trying to find is, so the output is a probability. No, the input is a probability. The output is a z value. Okay, you guys can hear me? Yeah, 0.5. So what I'm trying to do is, let me quickly show it in my notebook. So norm dot ppf, and I write something here. Okay, let's say x. So the input is x, which is nothing but a probability. Okay, and what is the output? The output will be z value. Okay, z value will be your output. Okay, so what am I trying to do when I write norm dot ppf and I write, let's say, 0.5? Okay, this x will always be less than equal to 1 or greater than equal to 0. Okay, it will always be like this. Okay, because this is probability. X is nothing but probability. So if I do this, what does this mean? What I'm trying to find? What am I trying to find here? I want to find that point for which the area on the left hand side is 50%. That is what this means. Guys, are you getting? I want to find that value of z for which the area on the left hand side is 50%. Okay, that's what it is telling me, right? So which is that point? Can you tell me, guys? So that this area is 50%, which is that point? That point is the mean. Exactly, that point is nothing but the mean. So how many standard deviations away from the mean is that? Z represents that, right? How many standard deviation away from the mean you are? So how many standard deviation away from the mean you should go to reach the mean? 0 standard deviation away. Exactly, you have to go 0 standard deviation away from the mean to reach the mean. That means your z is 0. Okay, and what does z mean? Z is nothing but x minus x bar by sigma. So from this you can calculate, you know the value of sigma, you know the value of x, you can calculate your value of the x also. So in this case it will be 0, because this will go here, it will become 0. X bar plus 0 is, again, you will get x is equal to x bar. Okay, so the z value basically will be 0. So the output of that function will be z value. Okay, so that is why when you run this, you should get 0. So see, I'm getting 0 here, right? I'm getting a 0 here because you have to go 0 values away from the mean to get 50% of the area. Okay, now similarly, coming to the question which I asked you, let's try to do that question using this function. Okay, what was this question? In this question, what was the question was that, so we were moving 2 standard deviation away, right? And how much area did we get? We got an area of 97.25, I think, right? Yeah, this is what we got. Okay, 97.75. So let me write that here, 0.9775. So if we run this, it should give us a z value of whatever we got here, z value. Okay, it should give us that z value. So if I run this, it is giving me 2. See, it is giving me 2. So we move 2 standard. So I'm doing it in a reverse way. Here we calculated the area, and then from the z value we calculated the area, but right now I'm calculating the z value from the area. Okay, so I gave the area already, and then I'm trying to calculate the z value. See, z value we got 2. From that we calculated the area here, right? Now I'm doing the opposite of that. From the area I'm calculating the z value, and I'm getting the same answer. See, I'm getting 2 as the answer. So note down this function, guys. Okay, I will share this notebook anyways. So this is normal dist functions. Okay, so you can run this function. So use this function when you are solving these questions. Okay, So for example, for the last question, you will need that function. You will need this function for the last question. You can do this in Excel also, by the way. All these functions are present in Excel also. So let me show you how you do that in Excel. So let me just open up one Excel file. Though don't try to do this in Excel. Maybe if you want to verify, you can try this in Excel, but otherwise do that in Python. Okay. Oops. Okay. So you just write norm. Oops. Okay. You just write norm. See, you will get so many functions based on normal distribution. So see, you get the help page also. Returns the normal distribution for a specified mean and standard deviation. This is returns inverse of normal distribution. Okay. This is the same. This is same. So you can use any of these. Okay. I want to calculate. So see, it is asking for the probability. So what is the probability? I will give 9775, right? This is what we gave. And what is it is asking me for the mean. So for the mean, what was the mean? Oops, how many Excels did I open? Oh, I think I opened two. Okay. So if I go back to the question, what was the mean we had? We had a mean of 65 and standard deviation of 10. So I can directly give those values. I can give a mean of 65, standard deviation of 10, and I press enter. See, it is giving me 85. Mean was 65 and standard deviation was 10, right? It is giving me 85. So 85%. Okay, no, I think this should be 85, right? I don't want mean and standard deviation. Yes, so 85 I'm getting. So 85% of my 85 is the marks below which I get 97.75 of my area basically. So what I wanted was 1 minus this, right? So what I wanted in the question was 1 minus of this, which was, okay, this should be in decimals, right? No, this is marks. So 85. Okay, so this was not my question. I'll have to use the other function. So not norm inverse, I'll have to use the normal distribution. So I'll write the x. X is nothing but 85. Mean is 65. Mean is 65. And then standard deviation was 10. Okay, you see I get that area. So below 85, and if I want above 85, I will just subtract 1. See, I'm getting this number. I can just multiply this number with my total number of students, which was 60, and I'm getting the same answer. This is what we got here, right? So the same thing I have done here using Excel. So don't worry about Excel, but you can verify your answers in Excel also. It is pretty simple. Okay, the same Z test you can do in Excel also, and you get the same answer, 1.36. Here also we got the same 1.3 we got here also. Okay guys, so don't worry, just follow this. So in Python, this is the command if you want. This is the command if you want Z value out. Okay, similarly you will have a command if you want the probability out. Okay, if you want the probability as output, you can use this particular function. So let us see what is that function if you want the probability out instead of the Z value. Just a minute. Kind of forgot what is the function for that. Let me try with norm dot. I think, is it this one? Cumulative distribution function. If I give, let's say, 50% here, now I will give the z value. Basically, I want to go zero standard deviation away. It should give me 50% now. Yeah, so this is the other function. If you want the probability out, this is what it should give you. Okay, and it always gives you the area from the left hand side. Okay, from the left hand side it will give you the area. So I have given the z value now. Now z is my input and probability is output. Okay, so input is z and output is probability. Okay guys, are you getting, guys, this one? I know it's a little difficult. It's a new topic, totally new topic for you, but I think you should get it. Okay, so try to read this again before tomorrow's class. Okay, or let's do one thing. Let's do a few examples. Then it will become pretty clear. Let me allow you guys to do it. So let's do at least this one example. Let us do, and the other three I'll give you as homework. Okay. So let me hide the answers. Okay. So try to do this example. You have these formulas here. So open a Python notebook, use these formulas, or you can use Excel if you want. Okay. Use these two formulas and try to solve this question basically. Let me, how do I show you both of this? Yeah, now both is visible. Okay, try to do this, guys. Try to solve this question. So quickly try to solve this. Let's see. Okay, let me hide the solution. Okay. Yeah, try to do this. Tell me when you're done, okay? Yes, 50% means 50 percentile of the data. Exactly. Bharat. Okay. So if your z is 1, 2, or 3, if your z is either 1 or 2 or 3, then you can always remember from here that 68%, 95%, and 99.7%. But if your z is a decimal place, has a decimal value, then you will not be able to remember, right? So then you will have to take help of a software, and that is what we are trying to do. And more often than not, we will have z values which are in decimal places. Okay, so try to solve this. I'll be back in 2 minutes. Okay, try to draw the figure, try to shade that figure based on whether you want left hand side or you want right hand side. So try to do this, guys. This is very important. Okay, and this, a lot of questions are asked from z test or t test. Guys, anybody got the answer? Are you trying? Okay, good. Yeah, that's okay. Try on your paper. So here I'm asking, the question is what is the probability? Okay, so I'm asking the probability. So which function gives you the probability? This will not give you the probability. This takes input as a probability. Okay, so you'll have to use the second function, norm.cdf, cumulative distribution function. This you'll have to use to get the probability. Okay, and what input does it take? The input it takes is z value. So, okay, so z value you will have to calculate from the question and feed in this function. Yeah, Bharat, so what output are you getting? What is the output of that? I'm not sure. I'll have to calculate. Okay. Guys, it has to be less than 50%. It cannot be more than 50% based on normal logic. Okay, this sounds reasonable. 28 or 23. But why such a strong variance? 28 and 23 or 27 approx, but still 23 and 27 is not close. So you are missing something, one of you. Try look into that again. Okay, great. So now let me try to do it. Okay, just 1 minute. Okay, let's see which one is correct. So this was a pretty simple question, very similar to what we did, right? Okay, so PPT question or homework question 1. Okay, so what was the question? What was the mean given to us? The mean given to us, guys, somebody tell me. I don't have the question open, right? What was the mean? 80. Okay, so 80 was the mean. What was the standard deviation? 10 or 16. Okay, and what was the question? The question that was asked is, what is the percentage of students scoring 90 or more in the exam? Okay, so the question was, if this is my normally distributed marks, my mean is somewhere here 80. My question is, what is the percentage of students who got 90 or more? So that means right hand side, right? This is your 90 or more, right? So some of you wrote 72 as the answer. How can this be 72? It has to be less than 50% because we know that this total is 50%. So obviously this will be smaller than 50%. Okay, so it cannot be more than 50%. So this is what we have to find. So let's find the z value first. So we are doing a z test. We'll find the z value. The formula is x minus x bar divided by sigma. X is your 90, x bar is 80, sigma is 16. So 10 divided by 16. Okay, this is your 10 divided by 16. It's 0.625. Okay, so my z value is 0.625. Now here comes the situation where we do not know. We know that if we go one standard deviation away, we get 68%, but we don't know how much we get if we go zero point 0.6 standard deviation away. So we will have to take the help of software in this case. Okay, so which function will be used? Let's come back to the function. Now this function, it takes probability as the input. Okay, and it gives us z value as the output. Okay, it gives us z value as the output. We don't want this. We want z value as the input and probability as the output, right? That is what we want. So we will use norm.cdf function. So very simple, we will just write norm.cdf and we will write whatever z value we got. So what we got? We got 0.625. So I will just write 0.625. Okay, so this will give me. So if I do that, so the area that the formulas give you, it is always from the left hand side. Okay guys, the formulas give you the area always from the left hand sides. Oops, what is this? Okay, let me write it here, otherwise. Probability or area from left hand side. Okay, this is very important. So if I run this, I get some area which is 73%, but this area is the area from the left hand side. Okay, not from the right hand side. So it is giving me this particular area. But if I have this, I can always find this, right? So the area that I got is 0.733 or 73%. So I know now my answer is, I know my answer, it is 1 minus 0.73. So almost 27%. Okay. So 27% is the answer to this question. Okay guys, is it clear to everybody? So let me go back here and let me undo. So the answer, you see, it is 26.59. So 27%. Don't worry about this code. This code is for R. Okay. So Yashwant and Prajwal will remember this. We did this in the class as well. So this is for R. Don't worry about this. But for Python, you will use. Let me write that down as well. So for Python, you will. Or let me write it down for Python. It will be norm.cdf. Okay. And you write the probability here. Okay. And before that you will have to write from cipy dot stats import norm. Okay, and this is small, not capital. Okay, so there can be hundreds of sorry, it's z value or z not probability. Which one Aurangzeb? Okay, yeah, this is the z value. The output is a probability. Yes, you are right. So this is the z value. Sorry, yeah, thank you. Yeah, this is a z value. Okay. So the other 2 3 questions that I have in the PPT, I will send that as a homework. So please try that, guys. Okay. So I think we are already out of time. So a very important concept we saw. We saw what is. So let's do a quick revision. Okay. Before we conclude today's class. Okay, guys. I hope everybody understood today. We saw a very important statistical concept. Let me save this. Let me open up a new file. Okay. Let's start with revision. So revision for day 5. Okay. So what did we see? Let's start in the hierarchy. So we spent a lot of time revising the entire course today. Okay. We lost almost 40 minutes in revising the entire course, but that was good. We got a very quick revision of everything that has been covered so far. Okay. After that, we started. What was the first thing we saw? We saw concat function, right? Concat function is used to combine two data frames. Okay, either combine in this way or combine them in this way, one on top of the other or one below the other. If you do this, you give axis is equal to 1, that means column. If you do this, you give axis is equal to 0, that means row concatenation. Okay, the function looks like this. Concat, you write the data frames here, and you write axis is equal to 1 or 0, depending on what you're trying to do. This is the concat function. Okay, guys, tell me if you have any doubts. Next, we saw merging two data frames. Very important. Concat is used only if the column names are same. This column name is the same as this. Okay, then only you can use concat. Otherwise, it wouldn't make sense. It will not do also. It will throw you error. If your column names are different and if you try to do this, it will throw error. Now merge is very important when you have one common column between two data frames. Okay, the primary key or the foreign key that it is called. Okay, so which is common. So this maps to another column which is here. So these two are common, and based on that you want to create a new data frame which has everything. Okay, so we saw what is a left join, we saw what is right join, we saw what is inner join, we saw what is outer join. Okay, the syntax was pd dot merge, give the data frames that you want to merge. Okay, and then you write how is equal to any of these, any of these will come here, and on is equal to, within quotes you write the column on which you want to merge. So this particular column, let's say k, so you will give k here. Okay, clear guys? Again, I will not go into the concepts, what is left join, what is right join. Left join is when your left, so left join is when your left, the data frame which is at the beginning, which is on the left hand side, so this is your left, this is your right, so your data frame, left data frame becomes the base, and all other columns from your right side start getting added. Okay, similarly right is when right becomes your base and all the columns from your left start getting added. This is your left join. Inner join means you will not have any NA. There will be no NA in your data if you are doing an inner join in your outcome. Outer join means it will have the most number of NAs. Okay, but you will not miss any information. You will not miss any info if you do a outer join, but you will have NAs in data. Here you miss max info, but you won't have any NAs. Left join means you will miss info which is present on the right hand side but not in the left hand side. Okay, right join means you will miss info which is on the left hand side but not in the right hand side. Okay, this is the merge operation in Python or in any other language. Okay, this is how merge works. What else did we see guys? After this, what did we see? We saw group by, right? Very important. Group by is again used to aggregate a data frame based on some column. Okay, to do some operation on a data frame based on some column. So for example, the syntax was data frame dot group by. Okay, then we wrote based on which column do you want to group. Okay, you wrote that column here. You can have multiple columns also, and then here you wrote you want to find something of on which column. So if I remember, we had sales here, right? And we had the unit here in the example which we discussed, and we wanted to find the mean, so we wrote the mean here. Okay, this is how the syntax looks like. Okay, now if you want to do multiple operations like this, you can use the AGG aggregate function. Okay, so we can use data frame dot group by, very similar syntax. Write the column on which you want to group. Here also similar, on which column do you want to perform some operation. Dot AGG you write, and here you write whatever you want to perform. You can write np dot mean, np dot max, or np dot std. Std is if you want to calculate the standard deviation of this column, then you can get the np dot std also you can write. This function calculates the standard deviation in Python. Okay, so this is your group by in Python. Anything else did we cover guys? Before moving to the z test, the normal distribution, did we cover anything? Okay, no. So now let us jump to the statistics part now. Okay, yeah, we covered the missing value. Kavya, thank you. So the missing value part, how do we identify missing values? Okay, so first we learned how do we drop missing values. Okay, we just write data frame dot drop, and we write axis is equal to 1 or 0. If you write axis is equal to 1, all rows, all columns having missing values will be dropped. If I write axis is equal to 0, all rows having missing values will be dropped. Okay, next we saw how do we fill missing values using the fill na command. Okay, so very simple, data frame dot fill na, and here we write value is equal to some particular value. We give that value, so that value will fill all the NAs in your data frame df. but this is not usually done. We do it one column at a time. So we will usually do it this way. We will select one column and then we will fill the NA with mean, median, or whatever value. Okay, one column at a time we do. We don't fill values in all the columns with the same value. Okay, so this is your fill NA. Next, what did we see? We saw how do we identify NAs in our data. Okay, how do we identify NA? So how do we do that? We use is null function for that. Okay, is null function. Okay, so is null function will give you, if you run this, it will basically check for each element in your data frame whether it is null or not, whether it is NA or not, and it will give you a series of true false. Okay, but if you want to basically find column wise how many values are null and how many are not, you can write this function data frame dot is null. Just add these values because we know true is 1 and false is 0. So just write dot sum. This will give you column wise. So if this is A, B, C, D, it will give you column A how many missing values, B how many missing, C how many missing, and D how many missing. So it will give you these values. So this is how you can identify missing values in your data. Okay, so missing values identification, filling the missing values or dropping the missing values. Okay, anything else, guys? No, I think this was all. Okay, so next we jump to normal distribution. So again we saw some basic characteristics of a normal distribution. Okay, what did we see? If this is our mu and this is our sigma, if we go from mu minus sigma to mu plus sigma, we get 68% of the population. Okay, 68% of the population we get. Similarly, if we go mu minus 2 sigma to mu plus 2 sigma, we get 95.5% of the population. And similarly, 3 sigma to this we get 99.7%. Okay, beyond that we get almost everything. Okay, because here itself we have covered almost 100%, so we never go beyond that. Okay, because these lines they almost touch the x-axis after this, but theoretically they never touch. Okay, practically they touch, but theoretically they go till infinity. They never touch your x-axis. Okay, theoretically. Practically after 4 standard deviation you will never find any value, but theoretically you may have. Okay, so this is a normal distribution. Then what did we see? We saw what is z-test. So what is z-test? Z-test is nothing but if you have to basically find how many z value. Okay, z value is very important in z-test. Z value is nothing but how many standard deviation away is your point, okay, from the mean. Okay, you can calculate this by using this formula x minus x bar by sigma. Okay, this gives you a z value. Now using your z value you can find your probability. So you have that Python function where your input is z value and output is your probability. Okay, probability. Similarly, you have another Python function where your input is probability and output is your z value. Okay, and if you have the z value, you can always find, if you have your z value, you can always find this particular x, because this will anyways be given to you, this is given to you, and this you are getting from this other function. Okay, now if your sample size is small, we cannot rely on a z-test. In those cases we go for a t-test. Okay, there also it is same, you calculate a t value which is nothing but the same formula. Okay, but the only difference is between a z-test, this is used for a sample size less than 30. Okay, if your sample size is less than 30, you use a t-test. And the difference in the distribution of z and t is, if this is your z If this is your normal distribution, your tree distribution will be something like this. Okay. Okay. So it has wider tails. Okay. T distribution. T distribution has wider tails. Okay. This T test is also known as student's T test. Okay. Student's T test. Okay. Why students? Because the person who found this, he used a pseudonym of student. He was using a pseudonym of student, so he named it on this. So it's called student T test. Okay. So I hope you understood everything covered today, guys. What do you think? How did the class go? Did you understand? Was it good? Boring? How do you find statistics? Yeah, there is a lot to come actually. So we have another test called chi-square test, which I will cover not tomorrow. I don't want to cover all statistics at once. Maybe after some days, next week we'll try to cover. When we use it in our algorithms, at that point I will try to cover chi-square test. But try to learn z-test on your own also. So I have explained you what z-test is. Try to Google some stuff on this. Maybe YouTube. Go to YouTube videos. Go to Khan's Academy. Just Google z-test and Google t-test, and you will basically it will be a revision of whatever I have told, because I followed a certain procedure to help you explain and to help you understand z test and t test. Okay, if you follow any of the videos, they might have followed something else or some other examples they might have taken. Okay, so sometimes it might convince you better, but it might, on the other hand, it might also confuse you. So I'm not sure, but try to see some videos. If it confuses you, just drop it. Okay, because z test t test can be used in a variety of cases. So if it is confusing you, just drop it. But if it helps you understand, it's good then. Okay, but try to read this once from any resources other than what I have covered. Okay, there are plenty of resources on Google. Just Google and you will know. And the homeworks I'll be mailing to you right away. Immediately after this, I'll mail you the homework and the notes that I have prepared. But the videos you will get only by late evening today. Maybe around 11 or 12, I'll send you the videos link, because it takes a lot of time to prepare the videos. Okay. So I hope you guys like the class today. We will have a similar class tomorrow, which will have a lot of statistics. Okay. So I hope you guys are enjoying the class. We are yet to jump into machine learning, and the classes have already got very interesting. I'm also enjoying teaching you guys, and I hope you guys are enjoying it too. Oh, thank you, Bharat. It means a lot. Thank you. Yeah, tomorrow's class timing is the same, guys. So sorry, I forgot to send out a invitation for that. The same timings we will have. Okay, 2 to 6. Okay, I will send you a request maybe now or maybe after some time. Okay, it is the same timing. So we will follow the same timings unless something urgent comes up to me or to anybody, and if everybody is okay. Okay, Karthik will not be able. No problem, Karthik. You can watch the recordings. Okay. So tomorrow we'll do more of Python than of statistics. Okay. So today we covered a lot of statistics. Tomorrow it will not be. Tomorrow it will be like not much of statistics. It will be more of Python tomorrow. Okay, and next week we are starting with machine learning. So next Saturday we will have our first machine learning algorithm, which is linear regression. Okay, guys. So thank you everyone. So let's conclude for today and enjoy your Saturday. You still have some time. Enjoy your Saturday, but don't forget to revise the things once at least. Okay, before tomorrow's class. Okay. So thank you everyone. I'll stop the recordings now.